When the comet known as 3I Atlas first entered the inner reaches of the solar system, astronomers expected a relatively ordinary interstellar visitor. Its trajectory, brightness, and estimated size placed it among the growing list of objects that had wandered into our celestial neighborhood from the deep gulf between stars. Yet, as 3I Atlas approached the orbit of Mars, the instruments aboard several solar observatories began to register something no one had anticipated: subtle but unmistakable distortions in the solar wind. The flow of charged particles streaming outward from the sun, a constant gale of plasma that sculpts planetary magnetospheres and drives auroras, was being bent around the comet in ways that defied current physics. What began as a curiosity quickly escalated into one of the most puzzling astronomical events in recent memory. Before we start, hit the like and subscribe buttons for more exclusive news. The solar wind is not an easy thing to bend. It is a supersonic river of ionized gas traveling at hundreds of kilometers per second, guided and modulated by the sun's magnetic field. Comets usually interact with it through a process known as ion tail formation. As their ices vaporize, the released gases become ionized and are swept backward, forming the familiar glowing tails seen even from Earth. But in the case of 3I Atlas, scientists saw something else entirely. Instead of the solar wind pushing the comet's plasma tail directly away from the sun, it appeared that the surrounding flow of particles was curving around the comet in a large asymmetric arc, as if space itself were being refracted. Solar and heliophysics teams across the world rechecked their data, suspecting instrument error or a calibration fault. Yet the bending effect persisted across multiple spacecraft and ground-based detectors. NASA's Parker Solar Probe, though far from the comet's location, recorded minute ripples in the magnetic field that seemed to correspond to fluctuations emanating from the region around 3I Atlas. The European Space Agency's solar orbiter confirmed these anomalies through remote sensing of the heliospheric current sheet, where the influence of the comet seemed to produce localized turbulence. None of these disturbances matched any known mechanism of comet-solar wind interaction. The comet itself was not massive enough to create a gravitational distortion of such magnitude. 3I Atlas measured only a few kilometers across, hardly sufficient to tug on the solar plasma, which is diffuse and essentially weightless in cosmic terms. Nor could it be explained by electromagnetic effects alone, since the strength of a cometary magnetic field, if one exists at all, would be minuscule compared to the sun's. Yet instruments showed that particles in the solar wind were diverting course near the comet as though encountering an invisible barrier or lens. At first, scientists considered the possibility that 3I Atlas was ejecting an unusually dense or magnetically active cloud of ionized material. Perhaps its nucleus contained metals or exotic compounds that produce strong magnetic currents when interacting with sunlight. However, spectral analysis revealed nothing particularly strange. Water, carbon monoxide, and simple hydrocarbons dominated its emissions, much like other comets. If there was something hidden inside, it lay beyond the reach of ordinary observation. As the comet drew nearer to the sun, the bending of the solar wind became more pronounced. Instruments recorded a widening shadow downstream of the comet, a zone where solar particles seemed to decelerate or deflect. Some researchers likened it to a miniature bow shock, similar to what forms ahead of Earth's magnetic field as it diverts the solar wind. Yet the geometry was reversed. Instead of a neat, bow-shaped compression, the distortion extended laterally, wrapping around the comet's trajectory in a spiraling pattern. It was as though 3I Atlas carried with it an unseen influence that twisted the solar plasma into a corkscrew as it passed. Observatories on Earth began coordinating continuous monitoring campaigns. Radio telescopes measured faint modulations in the background solar radio flux, suggesting interference between the wind's charged particles and some unknown oscillating field near the comet. Infrared detectors picked up a faint halo of heat emission that did not match expected sublimation rates. Space-based coronagraphs detected faint polarization shifts in sunlight scattering from the comet's coma. The evidence pointed to an interaction that went beyond chemical outgassing or magnetic induction. One intriguing hypothesis emerged from the field of plasma astrophysics, that 3I Atlas might possess a core material capable of generating its own electromagnetic resonance when struck by solar radiation. If its interior contains superconducting minerals or some exotic phase of matter preserved from the interstellar medium, then under certain conditions it might behave like a natural plasma antenna, re-radiating energy into the surrounding solar wind. This re-radiation could, in theory, alter the trajectories of charged particles, bending them in complex patterns. Yet the energy required to produce the observed deflection seemed far beyond what a few kilometers of rock and ice could provide. The mystery deepened when researchers noticed that the bending effect appeared to pulse. Every few hours, sensors recorded rhythmic fluctuations in particle density and magnetic alignment near the comet. The intervals were regular enough to suggest some internal process, perhaps rotation, but more consistent than a simple spin. The repetition evoked the behavior of pulsars or magnetars, though at an incomparably smaller scale. Could an interstellar object carry within it a magnetic remnant from another star system, still oscillating in tune with its origin? Astronomers traced the comet's inbound trajectory backward and realized that 3I Atlas likely originated from beyond even the nearest stellar neighborhoods. Its hyperbolic path suggested an ejection from a region of the galaxy where interstellar gas is denser and more heavily magnetized. There, dust grains and icy fragments might have formed under conditions that allowed magnetic domains to become frozen into their structure. If 3I Atlas preserved such domains, it might act as a relic magnet of alien space, an artifact of a field configuration utterly foreign to our solar environment. Yet the possibility that it was interacting with the solar wind through a magnetic memory did not fully account for the spatial scale of the distortion. The region affected stretched tens of thousands of kilometers across, dwarfing the comet itself. The bending wasn't local but systemic, influencing the flow of plasma in the wider heliospheric neighborhood. When researchers modeled the data, they found that the distortion could only be replicated by assuming the comet generated a region of altered space where the effective propagation of electromagnetic fields was different, almost as if the permittivity of the vacuum itself had changed. That notion brushed against the edge of known physics. Modifying the behavior of the vacuum requires extraordinary energy densities far beyond anything achievable by natural processes at a cometary scale. Yet the solar wind seemed to respond to 3I Atlas as though encountering such a region. Some theorists propose that the comet might be surrounded by a cloud of dark plasma, an unconfirmed form of matter interacting weakly with light but strongly with electromagnetic fields. If even a small amount of this material were trapped around the nucleus, it could theoretically channel solar particles in unexpected ways. As word spread through the scientific community, more observatories turned their attention to the event. Magnetometers on spacecraft orbiting Mercury and Venus detected delayed ripples in the solar wind consistent with the disturbances propagating outward from the comet's vicinity. The sun itself seemed to respond faintly as if feedback from the deflected plasma produced slight oscillations in the heliospheric current sheet. The event began to be seen not as an isolated anomaly, but as a systemic interaction, an interstellar body temporarily rewriting the local dynamics of the sun's outer atmosphere. For those studying space weather, the implications were profound. The solar wind governs much of what happens in the space between planets. It drives geomagnetic storms, influences cosmic ray propagation, and shapes the outer boundary of the heliosphere. If an object as small as a comet could measurably alter that wind, then our models of solar object interaction were incomplete. The idea that a foreign interstellar fragment could momentarily bend the very breath of the sun suggested that the medium of space might be far more responsive and far more complex than previously imagined. While many researchers remained cautious, a few dared to speculate about the underlying cause. Some invoked the concept of interstellar relic fields, vast magnetic structures stretching across light years that might leave imprints on objects traveling through them. If 3I Atlas had once passed through such a region, it might carry within it residual magnetic topology, a fossilized field geometry that could resonate under solar illumination. When bombarded by the sun's radiation, these embedded structures could awaken, coupling with the solar magnetic field and causing space around the comet to twist. Others leaned toward the idea of quantum scale effects. In this view, the bending of the solar wind was a macroscopic manifestation of vacuum polarization, a phenomenon where intense electromagnetic environments alter the properties of empty space itself. If 3I Atlas contained materials capable of amplifying such effects, it could act as a catalyst for small but measurable warps in the propagation of plasma. Though speculative, this theory captured the imagination of physicists who had long sought natural laboratories for testing quantum electrodynamics beyond Earth. The phenomenon also reignited debates about the diversity of interstellar bodies. Since the discovery of 1I, Oumuamua, and 2I/Borisov, astronomers had wondered how many different kinds of matter might drift between stars. 3I Atlas, with its ability to distort the solar wind, appeared to belong to a class of objects more exotic than any previously recorded. Its chemical composition, shape, and spin all seemed ordinary, but its interaction with space itself was extraordinary. It was a reminder that our solar system is not isolated, and that the galaxy may contain materials and phenomena beyond terrestrial experience. As the comet approached perihelion, the bending reached its peak. The solar wind in its vicinity slowed to nearly half its normal velocity, forming a vast region of turbulence and eddies. Instruments detected high-energy particles being accelerated within these eddies, a process reminiscent of the way cosmic rays are generated in supernova shocks. The comet seemed to act as a miniature accelerator, injecting energized ions back into the heliosphere. Researchers monitoring cosmic ray fluxes on Earth noticed slight increases correlated with the comet's alignment, an astonishing hint that even distant interactions could ripple across astronomical scales. In the midst of these discoveries, the visual spectacle of 3I Atlas captured the imagination of the public. Amateur astronomers noted that its tail shimmered differently from other comets, sometimes appearing twisted or braided as though following invisible magnetic threads. Photographs revealed faint arcs of blue-green light curling away from the nucleus in looping shapes never before documented. The comet's glow fluctuated rhythmically, echoing the periodic pulses measured in particle data. To the human eye, it was as if the comet were alive, breathing in sync with the solar wind it was reshaping. Space agencies scrambled to reposition instruments for closer observation. Plans were drafted for future missions to intercept potential interstellar visitors before they entered the inner solar system, so that their interactions could be measured in situ. The event underscored how little was known about the boundaries of heliophysics. If an interstellar fragment could create such large-scale effects, then understanding those effects was crucial for predicting space weather, protecting satellites, and grasping the broader physics of cosmic plasmas. The theoretical ramifications extended even further. Some cosmologists saw parallels between the bending of the solar wind and the behavior of plasma in the early universe, where magnetic turbulence may have shaped the distribution of matter. If 3I Atlas could produce small-scale analogs of those primordial conditions, it offered a glimpse into processes that occurred shortly after the Big Bang. Others drew analogies to laboratory plasma experiments seeking to confine fusion reactions. The comet, by deflecting charged particles naturally, might hint at principles that could one day inform new methods of magnetic confinement or particle control. As the days passed, teams compared data across multiple wavelengths. Radio emissions showed harmonics consistent with oscillating plasma sheets. Ultraviolet imaging revealed faint auroral-like curtains surrounding the comet, undulating in rhythm with the solar wind. The interaction zone became a theater of invisible forces, a ballet of charged particles tracing lines of mystery around a traveler from beyond the stars. Each measurement raised new questions. Was the comet generating these oscillations autonomously, or merely amplifying solar variations? Was the effect electromagnetic, gravitational, or something yet undefined? Attempts to model the phenomenon on supercomputers yielded tantalizing but inconclusive results. Simulations incorporating known plasma physics failed to reproduce the observed curvature of the solar wind. When researchers added hypothetical parameters, exotic conductivity, variable vacuum permittivity, or hidden magnetic domains, the models came closer but remained unstable. The comet's behavior seemed to straddle the boundary between known physics and something entirely new. In private conversations, some scientists admitted to considering ideas once relegated to science fiction. Could 3I Atlas be a fragment of a larger artificial construct, its composition deliberately engineered? The rhythmic pulses, the consistent deflection pattern, and the precise symmetry of its influence all tempted speculation about non-natural origins. Yet no evidence supported such claims, and most researchers resisted the allure of conjecture, preferring to wrestle with the puzzle through empirical means. Still, the sense that humanity was witnessing a phenomenon both ancient and novel pervaded every discussion. For planetary scientists, the implications reached into the heart of solar system formation. If interstellar bodies could alter local plasma environments so profoundly, then the influx of such objects in the early days of the solar system might have played a role in shaping planetary magnetospheres and atmospheric chemistry. The bending of the solar wind could have redistributed charged particles in ways that influenced how primordial gases accumulated or escaped. The comet's strange behavior might thus represent not just an anomaly, but a clue to the processes that sculpted our cosmic home. Throughout the phenomenon, the Sun remained stable, its overall output unchanged. Yet the region surrounding 3I Atlas glowed with dynamic energy, a microcosm of plasma physics in action. Spacecraft passing through adjacent regions reported transient surges in particle density, magnetic field direction, and radiation intensity. It was as though the comet were stirring the solar atmosphere with an invisible spoon, creating localized storms in the sea of space. The bending of the solar wind was not a gentle ripple, but a sweeping, sustained phenomenon that challenged every existing model. Observers began to realize that the effect might not be purely mechanical. Some theorists proposed that the comet was resonating with the Sun's own magnetic field lines, setting up standing waves that extended across millions of kilometers. These resonances could explain the periodic pulsations observed in both particle and light emissions. If true, it meant that 3I Atlas had effectively tuned the Sun's magnetic symphony, an interstellar tuning fork ringing against the chords of our star. The idea electrified the community. For centuries, the Sun had been seen as the dominant force, with planets and comets merely reacting to its output. Yet here was a small traveler from beyond the stars apparently capable of influencing, however briefly, the flow of the Sun's breath. The notion that such interactions could occur hinted at a hidden reciprocity between stars and the objects that drift among them, a galactic conversation conducted through magnetic whispers and plasma currents. Data from the heliophysics missions continued to stream in, revealing patterns of oscillation that seemed to propagate outward long after the comet had passed. The bending of the solar wind was not a static deformation, but a wave, echoing across the inner solar system. It carried with it subtle changes in particle velocity and orientation, like ripples spreading from a stone cast into a cosmic river. Each ripple told of the encounter between a star's outflow and an interstellar fragment bearing unknown properties. The implications for astrophysical research were vast. If 3I Atlas could bend the solar wind, then other interstellar bodies might influence the winds of their host stars as well. Across the galaxy, stellar systems could experience similar encounters, each leaving signatures in their magnetospheres and radiation belts. Over time, such interactions might even contribute to the evolution of stellar environments, seeding variability and turbulence that shape planetary climates. The bending of the solar wind might therefore represent not just a local curiosity, but a universal process linking stars through the passage of interstellar debris. Back on Earth, laboratories sought to replicate the effect using plasma chambers and magnetic fields. None succeeded. The parameters required to achieve even a fraction of the observed bending were far beyond current technology. The comet's influence remained singular and elusive, yet its lesson was clear. The space between stars is not empty but charged with mystery, and the smallest traveler can reveal hidden dynamics that challenge human understanding. As 3I Atlas moved deeper into the inner solar system, its luminous arcs became more vivid. Spectrographs captured emissions hinting at unknown atomic transitions, possible evidence of interactions between solar particles and materials never before encountered. The bending of the solar wind seemed to intensify with proximity to the Sun, suggesting that the comet's influence was reactive, feeding on the increasing density and energy of the solar plasma. The solar wind itself, normally a steady outflow, appeared to shimmer and twist in response, as though reluctant to yield its path. Scientists watched in awe as magnetic field maps reconstructed from spacecraft data displayed vast swirls forming near the comet's trajectory. The lines of force, usually smooth and radial, contorted into looping shapes resembling vortices. Some of these persisted even after the comet had moved on, slowly dispersing over days. The persistence implied that 3I Atlas had not merely deflected the solar wind, but temporarily altered the magnetic topology of the region, a feat no known natural body had accomplished. Every new data set added to the intrigue. The comet seemed to carry with it a field of influence that behaved as though detached from conventional matter, responsive yet independent of its visible structure. The bending of the solar wind might have been the visible signature of an invisible companion, perhaps a sheath of plasma formed during the comet's long interstellar voyage, retaining properties distinct from solar matter. Whatever the mechanism, it demonstrated that interstellar space could preserve and transport energetic configurations over unimaginable distances. The deeper the investigation went, the clearer it became that 3I Atlas had opened a window onto an uncharted frontier of astrophysics. The event blended plasma physics, magnetohydrodynamics, quantum field theory, and cosmology into a single, tangible mystery. It showed that even in the familiar arena of our sun's domain, there remain phenomena capable of defying expectation and reshaping understanding. The bending of the solar wind was not just a curiosity. It was a reminder of the living complexity of the cosmos, where every particle and field is connected in ways yet to be fully seen. The bending of the solar wind by 3I Atlas did not merely disturb magnetic maps and plasma readings, it unsettled something deeper in the collective imagination of science. There was a moment, brief but unforgettable, when the entire heliophysical community seemed to fall silent, suspended between disbelief and revelation. The comet had already exceeded expectations by surviving longer than its projected disintegration point near the sun's intense radiation. Yet as it drifted inward, not only did it endure, it began to reveal layers of behavior that hinted at structures or processes invisible to ordinary analysis. The airless vacuum surrounding it became alive with oscillations, subtle vibrations recorded across multiple instruments, echoing like a soft cosmic heartbeat. Every spacecraft that happened to be within observational range, Parker, Solar Orbiter, Stereo, even older probes like SOHO, detected strange harmonics in the plasma environment. The data were consistent, a rhythmic signature repeating at a frequency too low to be generated by known cometary processes. Plasma physicists began calling it the Atlas tone, a name that quickly found its way into research papers and conference discussions. No comet, asteroid, or interstellar object had ever sung in such a way. The tone itself seemed to modulate the behavior of the solar wind, creating interference patterns like those produced by ripples in water that overlap and cancel each other. This oscillation was not a single pitch, but a layered structure of harmonics, as if the comet were transmitting multiple frequencies simultaneously. Some thought it could be the result of ionized gases resonating with magnetic fields, while others speculated it was a byproduct of plasma vortices rotating within the comet's induced magnetosphere. Whatever its cause, it was clear that 3I Atlas was not a passive traveler. It was interacting dynamically, its presence stimulating responses from the environment, as if it were part of an ongoing conversation with the sun itself. During this period, a few researchers began to suspect that the comet's tail might act as a kind of natural antenna. When charged particles streamed past it, they could be modulated by the internal structure of the tail's plasma. This would effectively turn the comet into a gigantic resonant cavity, amplifying frequencies embedded within the solar wind. If true, this suggested that interstellar objects could serve as natural transceivers, relaying electromagnetic information across vast distances. It was a seductive idea, not merely that the comet could bend the solar wind, but that it might also encode or decode signals from the interstellar medium itself. The idea of natural communication through plasma resonances wasn't new, but never before had it seemed so tangible. Plasma physicists revisited theories of Alfvén waves and magnetosonic propagation, testing whether 3I Atlas could be producing self-sustaining oscillations by channeling the solar wind through magnetic gradients within its own ion tail. Simulations hinted at possibilities. If the comet carried within it materials that could polarize in the presence of electromagnetic fields, it might generate feedback loops between electric and magnetic forces, creating self-reinforcing waves. In simpler terms, it could sing because the sun was playing it like an instrument. As the phenomenon deepened, observers noticed that the bending of the solar wind wasn't uniform across all directions. The curvature varied depending on the comet's orientation and velocity relative to the sun's magnetic equator. The deflection became more intense when the comet crossed regions of higher solar wind density, as though denser plasma amplified the effect. It suggested that the process depended not only on the comet's intrinsic properties, but also on environmental conditions, an interaction rather than a one-way influence. The comet and the sun were performing a duet of sorts, each responding to the other's subtle cues. What astonished researchers even more was that 3I Atlas's behavior appeared to evolve over time. Early in its journey, the bending was relatively mild, a soft distortion in the plasma flow. But as it approached the sun, the distortion became increasingly structured. Instead of chaotic turbulence, the magnetic field lines began forming coherent patterns, spirals, braids, and nested arcs. These shapes bore resemblance to theoretical predictions of magnetic reconnection zones, where field lines break and reform, releasing energy. It was as though the comet were generating tiny laboratories of cosmic electricity, sculpting space with precision unseen in any natural body. The potential implications were staggering. Magnetic reconnection is one of the universe's most energetic processes, driving solar flares, auroras, and even certain types of astrophysical jets. If a small interstellar object could trigger such behavior on a localized scale, it might provide a microcosmic analog to much larger cosmic phenomena. Some speculated that comets like 3I Atlas could seed such processes throughout galaxies, acting as catalysts for magnetic restructuring wherever they travel. It placed comets in a new light, not as passive remnants of formation, but as active agents in cosmic magnetism. Meanwhile, back on Earth, data analysis centers were flooded with terabytes of readings. Every frequency, every photon count, every particle flux measurement was dissected in search of patterns. Statistical models revealed correlations between the comet's position and fluctuations in solar wind velocity thousands of kilometers away. These correlations followed a fractal rhythm, recurring at multiple scales, reminiscent of turbulence cascades in fluids, but occurring in plasma. It hinted that the comet's influence was not localized but hierarchical, affecting the solar wind at both small and large scales simultaneously. That fractal character intrigued chaos theorists and mathematicians. They proposed that 3I Atlas might be generating self-similar patterns through nonlinear coupling between electric and magnetic fields. Essentially, it was turning the smooth flow of the solar wind into a turbulent tapestry governed by strange attractors, regions in phase space where energy tends to cluster. This would explain why the bending patterns were stable yet dynamic, ordered yet unpredictable. Nature, once again, was revealing its affinity for complex beauty. As these ideas circulated, more instruments were trained on the comet. Spectrometers detected faint lines corresponding to elements rarely observed in cometary comas, traces of scandium, vanadium, and possibly even isotopes of nickel that didn't match known solar abundances. Their presence suggested that 3I Atlas had formed in a region of the galaxy with a very different chemical fingerprint. Each measurement added a piece to the puzzle. An object forged in alien conditions was now interacting with our sun in ways that defied prediction. The possibility that the bending of the solar wind was linked to exotic materials within the comet gained traction. Some mineralogists proposed that its nucleus might contain quasi-crystalline lattices capable of channeling magnetic fields. Quasi-crystals, known for their aperiodic but ordered structures, can interact with electromagnetic radiation in unique ways, creating diffraction effects not seen in regular crystals. If such structures existed within the comet, they could amplify local magnetic variations, essentially turning the body into a crystalline engine of field distortion. This was not mere conjecture. Laboratory experiments had shown that certain metallic quasi-crystals can exhibit unusual electromagnetic resonances. As the comet passed within the orbit of Mercury, the bending effect intensified to its maximum recorded level. The solar wind on the sunward side of the comet slowed dramatically, while on the opposite side it accelerated. Spacecraft instruments recorded gradients of pressure and velocity that suggested energy was being transferred between different regions of the plasma. It was as if the comet were absorbing energy from one direction and releasing it in another, a natural plasma pump operating on a planetary scale. No known process could easily account for this. The idea that the comet might host internal electric currents was considered, but such currents would require sustained power sources far greater than any chemical or radioactive process available. Theories turned increasingly speculative. One idea proposed that 3I Atlas could be exploiting induced currents generated by its motion through the solar magnetic field, essentially converting kinetic energy into electromagnetic distortion. If so, it was functioning like a moving dynamo, converting motion into field strength, a phenomenon that could rewrite our understanding of small body electrodynamics. Yet even this didn't fully explain the graceful coherence of the observed patterns. They were not random emissions but orchestrated waves, repeating in harmonic intervals. Some observers began to suspect that resonance was the key, that the comet's orbital period, rotation, and magnetic environment had aligned perfectly with natural frequencies within the solar wind. Just as a tuning fork vibrates in sympathy with a certain pitch, 3I Atlas might have stumbled into a resonant state with the sun's electromagnetic field. In that resonance, small effects could amplify dramatically, leading to the vast bending observed. The resonance theory carried poetic and scientific weight. If resonance could link a comet and a star, perhaps such phenomena were more common than realized. Interstellar objects might act as mediators of resonance between stellar systems, carrying field patterns from one star to another, imprinting distant signatures across light years. The galaxy could, in principle, be threaded with a hidden web of resonant exchanges, a cosmic symphony of stars communicating through the dance of plasma and magnetism. Even more extraordinary were the patterns emerging in the solar corona near the comet's perihelion. Remote sensing instruments detected localized brightening in ultraviolet wavelengths, forming concentric rings that appeared synchronized with the comet's pulses. These rings pulsed outward like ripples on a pond, expanding and fading as they merged with the ambient solar atmosphere. No one had seen anything like it. The comet seemed to be inducing luminous waves directly on the sun's surface, as though reflecting its own oscillations back toward the star that illuminated it. In that moment, the distinction between comet and star seemed to blur. For the first time, humanity witnessed an interstellar object capable of influencing the sun's outer layers in real time. The bending of the solar wind had evolved into an intricate feedback loop. The comet altered the wind affected the corona, and the corona in turn responded with ripples that modulated the very plasma flowing toward the comet. It was a self-contained ecosystem of energy exchange, operating across millions of kilometers yet maintaining coherence. Astrophysicists saw parallels with magnetic coupling observed in binary star systems, where plasma flows between stellar companions. 3I Atlas, though tiny in comparison, seemed to replicate similar dynamics on a miniature scale. This discovery hinted that magnetically coupled interactions might not require massive bodies. Under the right conditions, even a comet-sized object could participate in stellar feedback mechanisms. Such processes, repeated countless times across the galaxy, might play roles in the long-term evolution of stellar fields. As the days unfolded, an unanticipated side effect appeared. Instruments monitoring cosmic ray flux began registering subtle oscillations synchronized with the comet's activity. It seemed that 3I Atlas was somehow modulating the passage of high-energy particles through the heliosphere. These modulations, though small, indicated that the comet's bending of the solar wind had consequences beyond its immediate vicinity. It was altering how energetic particles propagated through interplanetary space, a feat suggesting that even transient objects could temporarily reshape the radiation environment of an entire solar system. The practical implications were profound. Spacecraft shielding, astronaut exposure, and communication systems all depend on stable models of cosmic ray flux. The realization that an interstellar comet could perturb these values even slightly forced mission planners to reconsider assumptions about deep space environments. If more such objects entered the solar system, and models suggested they do so regularly, then their effects might not be negligible. Each visitor could leave behind temporary distortions in particle flow, subtle yet cumulative imprints on the fabric of heliospheric space. Among the quieter but equally intriguing observations were the effects on light polarization. Starlight passing near the comet's vicinity exhibited slight but measurable rotations in its polarization angle. Normally, polarization changes occur when light passes through magnetic or dusty regions, but the pattern near 3I Atlas didn't fit either explanation. The light seemed to twist as if space itself were rotating its polarization, a phenomenon sometimes associated with quantum electrodynamic effects, or, in extreme cases, the influence of hidden fields. The bending of the solar wind, it appeared, was only one facet of a larger anomaly encompassing both particles and photons. This polarization rotation led some researchers to revive forgotten hypotheses about vacuum birefringence, the idea that strong electromagnetic fields can alter how light propagates through space. If 3I Atlas was somehow generating or concentrating such fields, it might provide the first natural example of vacuum birefringence observable at solar distances. That possibility sent ripples through the physics community. Laboratory experiments had attempted for decades to detect the effect under controlled conditions. Now, the cosmos itself might be demonstrating it unbidden. The comet continued on its path, its behavior shifting subtly as it rounded the sun. Observers on Earth caught sight of its tail splitting into multiple filaments that intertwined and then rejoined, as though following invisible braids in the magnetic field. These braids pulsed with faint light, creating ghostly serpents of luminescence that trailed behind. Some thought they might be visual manifestations of the solar wind's deflection lines, illuminated by ionized dust. Others suspected they were emissions from excited states of molecules influenced by fluctuating fields. Whatever the case, the display was mesmerizing, artistry born of physics beyond comprehension. Amid all this wonder, an undercurrent of tension grew within the scientific community. The inability to explain the phenomenon with established physics stirred both excitement and unease. Was humanity witnessing the limits of known science or simply missing an elegant but hidden mechanism? Theories proliferated. Exotic matter trapped within the comet, relic magnetic loops from interstellar clouds, induced plasma solitons traveling along its tail. Each proposal was bold, each met with scrutiny, yet none could fully reconcile the data. The bending of the solar wind remained an open enigma. The more data poured in, the clearer it became that 3I Atlas was a nexus where multiple disciplines met. Plasma physicists, quantum theorists, cosmologists, and material scientists all found pieces of their respective puzzles reflected in its behavior. It was as though the comet had arrived to challenge every silo of knowledge, demanding a synthesis of ideas rather than isolated explanations. Its effects were not confined to one domain. They spanned from the microscopic to the cosmic, from quantum fields to solar atmospheres. In long nights at observatories and data centers, researchers began to talk less about solving the mystery and more about learning from it. Perhaps the bending of the solar wind was not an anomaly, but a revelation, a reminder that nature operates through interconnected layers of resonance, field, and feedback. The comet had simply drawn back the curtain for a moment, letting observers glimpse the machinery behind the cosmic wind that shapes worlds and drives stars. Even the philosophy of science was touched by the event. It reminded many that the universe is still capable of surprise, that certainty is transient, and that humility is the only proper stance before cosmic complexity. The sight of the solar wind, once thought to be a predictable stream of particles, warping and swirling in obedience to an unassuming traveler from another star, was a humbling spectacle. It emphasized that discovery often comes not through prediction, but through astonishment. Yet the bending persisted, sustained beyond the comet's closest approach. As it began to move outward again, the distortion slowly weakened, but did not vanish. Residual oscillations lingered, propagating along the solar wind like echoes fading through a canyon. This suggested that the comet had imprinted a pattern onto the flow, one that would persist long after it departed. Instruments detected faint spiraling signatures months later, drifting outward into the heliosphere, a trace of its passage, an electromagnetic fossil embedded in the solar wind. Some compared it to the wake left by a ship in the ocean, a visible testament to motion and interaction. But unlike a ship's wake, these ripples could travel indefinitely, carried by the solar wind far beyond the reach of any probe. In time, they would merge with the broader currents of interstellar space, blending into the galactic medium. Somewhere, light years away, another star's wind might someday encounter the faint residue of 3I Atlas's passage, a whisper of its encounter with our sun. The notion of these cosmic echoes captured imaginations beyond science. Poets and philosophers saw in it a metaphor for the persistence of influence, the idea that every traveler, celestial or human, leaves ripples behind. The bending of the solar wind was not just a physical phenomenon, but a story of connection, a reminder that even across emptiness, interactions endure. Meanwhile, astronomers prepared for the next phase, observing the comet as it retreated from the sun. Many expected the effect to cease once solar radiation weakened, but preliminary data hinted that the anomaly might behave differently. As 3I Atlas moved outward, the bending became less pronounced, yet more structured, as if the comet were stabilizing into a controlled state. The solar wind around it formed concentric shells of varying density, like the rings of a tree. Each shell seemed to correspond to one of the rhythmic pulses detected earlier. It was as though the comet had stored the energy of its encounter and was now releasing it gradually into the surrounding plasma. That slow release fascinated researchers. It suggested memory, a kind of persistence of field configuration independent of continuous energy input. In other words, the space around 3I Atlas remembered the bending event. The magnetic and electric fields retained coherence longer than theory predicted. This could only happen if the fields were self-sustaining, maintained by trapped plasma, or by structures akin to magnetic knots known as spheromacs. If the comet had indeed generated such formations, it would represent the first naturally observed instance of a stable spheromac in interplanetary space. The possibility that interstellar objects could create and carry magnetic knots across star systems opened an entirely new avenue of thought. These knots could act as carriers of magnetic information, preserving patterns of field topology from one region of the galaxy to another. Over eons, they might accumulate, influencing how cosmic magnetic fields evolve. The comet then was not just bending the solar wind, it was transferring a message written in the language of magnetism. Such ideas blurred the boundary between astronomy and cosmology. If the galaxy were filled with travelers like 3I Atlas, each bearing fragments of ancient magnetic patterns, then the interstellar medium could be seen as a living archive of field structures. Stars, comets, and nebulae would all participate in an endless exchange of magnetic information, each encounter rewriting a portion of the cosmic script. The bending of the solar wind by one small object became a microcosm of that grand conversation, a single note in the symphony of galactic evolution. As 3I Atlas continued outward, its luminosity diminished, but the data continued to astonish. Instruments far from the sun recorded delayed reactions, perturbations in particle flow arriving weeks after the comet had passed a given region. These delayed effects hinted at the complexity of plasma memory, showing how charged particles can preserve disturbances and transmit them across space like invisible messengers. The comet's influence, though fading, had become woven into the heliosphere itself. For scientists watching from Earth, there was a growing sense of awe mixed with resignation. They had witnessed something extraordinary, something that stretched the edges of known physics. Yet they knew that full understanding might take decades, perhaps centuries. The data would be studied, reinterpreted, and reanalyzed by future generations, each finding new meaning in the patterns left by 3I Atlas. And even as the comet moved farther into the darkness, the sun seemed subtly altered. Some measurements hinted at minor changes in the orientation of magnetic loops in the corona, tiny but measurable. Whether these shifts were coincidental or consequences of the comet's visit remained uncertain, but the suspicion lingered that 3I Atlas had done more than just pass through the solar system. It had touched something fundamental, something that left a faint but persistent mark. The post-encounter analyses revealed subtle asymmetries in the solar magnetic field that persisted for months. Some researchers proposed that the comet had induced a minor reconfiguration in the heliospheric current sheet, a vast structure that divides regions of opposite magnetic polarity. If true, This would mean that a body no larger than a mountain had briefly shifted one of the sun's most extensive magnetic structures. It was an extraordinary possibility. A visitor from another star, briefly rewriting the invisible architecture of our star's breath. Data from multiple solar observatories showed faint undulations propagating outward from the region where 3I Atlas had once passed. These undulations moved slowly, as though the solar wind itself were digesting the memory of the encounter. In magnetograms, they appeared like long ripples spreading across a pond, oscillating between compression and relaxation. Their periodicity did not match any known solar rotation pattern or coronal mass ejection profile. They were something new, a residual echo of interaction. On Earth, teams began to model how these oscillations could affect the near-planetary environment. If the comet had seeded long-lived disturbances in the heliosphere, those disturbances might influence how the solar wind interacts with planetary magnetospheres. Early models suggested that such perturbations could alter the distribution of energetic particles around Earth, perhaps subtly affecting the shape of the magnetotail. Though the effects would be minor, they hinted at the interconnectedness of the system. Even a single transient visitor could influence conditions millions of kilometers away. This notion prompted a re-evaluation of other unexplained space weather anomalies. Historical records were revisited. Strange fluctuations in cosmic ray levels, unexpected auroral patterns, or brief magnetic drifts that had been dismissed as instrumental noise. Could some of these have been caused by earlier unnoticed interstellar visitors? Before 1I Oumuamua, no one had seriously considered the frequency of such encounters. Now, with 3I Atlas as proof that such bodies could actively shape their surroundings, past data seemed to shimmer with new possibility. The concept of cosmic resonance gained further weight when physicists identified faint correlations between the comet's pulse frequencies and the natural oscillation modes of the heliosphere. The sun's magnetic field resonates on multiple scales, producing waves that travel outward through the plasma. Somehow, the periodic signals associated with 3I Atlas matched one of these global modes. This could not be coincidence. It implied that the comet's interaction had synchronized with the solar system's own rhythm, like two instruments playing in harmony. The idea of synchronization fascinated theorists. They imagined the solar wind as a vast vibrating medium and the comet as a temporary node of reinforcement, a place where waves amplified each other. When those waves eventually dispersed, they carried traces of that interaction outward, possibly even beyond the heliopause. This led to a new field of speculation, that the interstellar medium itself might be a chorus of such resonant interactions, each star's outflow shaped by the brief crossings of wandering fragments from other systems. As the comet retreated toward the outer solar system, its brightness dimmed, but its influence remained traceable. Radio observations continued to pick up whisper-faint fluctuations in the low-frequency background. They followed the comet's trajectory like a fading melody, decaying yet persistent. At the same time, particle detectors aboard distant spacecraft recorded slight variations in the directionality of incoming solar particles, tiny but measurable angular shifts, suggesting that the wind still carried residual vorticity from the encounter. One of the most puzzling revelations came from the analysis of the comet's own reflected sunlight. Even as it moved farther from the sun and cooled, 3I Atlas displayed polarization characteristics inconsistent with simple scattering by dust and ice. The light appeared to have been altered by a medium that twisted its electric vector in a systematic way, as though the region around the comet retained an organized magnetic lattice. That coherence, surviving weeks after direct solar contact, defied conventional understanding of plasma diffusion. Space, it seemed, refused to return to equilibrium in the wake of the encounter. The persistence of structure raised deeper questions about the nature of the interstellar material that composed the comet. Perhaps its nucleus was not uniform at all, but a matrix of conductive filaments and dielectric inclusions, an intricate composite capable of storing electromagnetic energy. Some researchers compared it to a natural capacitor, slowly discharging the energy it had absorbed from the solar environment. Others envisioned it as a superconducting relic from regions of the galaxy where temperatures and pressures had frozen exotic phases of matter into stability. If such materials were real, they might preserve magnetic fields indefinitely, carrying ancient imprints from the cosmic web itself. The idea that matter could remember magnetism resonated across disciplines. Planetary geologists recalled how terrestrial rocks record Earth's magnetic reversals, locking in directions of ancient fields. Could 3I Atlas represent the interstellar equivalent, a messenger carrying the magnetic history of another star system? If its internal structure retained fossilized field orientations, the interaction with the solar wind might have reactivated them, producing the bizarre deflections observed. The comet could thus be seen as a living archive, a magnetic fossil waking briefly under the sun's warmth. As debates intensified, so did the efforts to find comparative examples. Archives of comet observations were combed for any sign of anomalous plasma behavior. A few minor cases surfaced, small irregularities in tail alignment or unaccounted disturbances in ion flow, but none approached the magnitude or elegance of 3I Atlas's phenomenon. Still, the existence of even weak analogs hinted that similar physics might occasionally unfold, hidden within the background noise of space weather. Gradually, a vision began to emerge of the solar system as a responsive organism. Every passing body, every burst of radiation, every plume of gas contributed to its changing texture. The bending of the solar wind by 3I Atlas revealed that the sun's domain was not a static stage, but a living fabric, sensitive to the faintest touch. When an interstellar traveler entered that fabric, the entire system trembled slightly, its magnetic nerves quivering in recognition. At observatories worldwide, the comet's data became a catalyst for collaboration between disciplines that rarely spoke before. Plasma physicists discussed quantum coherence with condensed matter theorists. Cosmologists compared galactic magnetic maps with solar measurements. The shared realization was that the same principles, field coupling, resonance, nonlinearity, applied across vastly different scales. The comet was a microcosm linking the infinitesimal with the cosmic. Within laboratories, small-scale experiments attempted to recreate aspects of the interaction. Using high-energy plasma jets and magnetic coils, scientists tried to replicate the curvature seen in the solar wind. Some managed to produce miniature analogs of the bending effect, though none approached its stability. In these tests, even slight irregularities caused turbulence and collapse, whereas 3I Atlas had maintained coherent structures for days. That endurance suggested self-regulation, as if feedback between the comet's fields and the solar environment sustained equilibrium. One particularly bold hypothesis suggested that 3I Atlas might have generated a form of plasma confinement analogous to magnetic bottles used in fusion research. In such configurations, magnetic lines curve around charged particles, trapping them in oscillatory motion. The comet's wake could have formed a vast natural containment field, holding plasma in looping orbits and thereby preserving its shape. If this were true, it would mark the first observation of self-sustaining magnetic confinement in nature, a phenomenon long sought in laboratories but achieved accidentally by a wandering fragment of ice and dust. Beyond the physical intrigue, there was something almost philosophical about how this event unfolded. The instruments that recorded the bending had been designed for entirely different purposes: solar flare forecasting, coronal mass ejection tracking, radiation monitoring. None had been intended to study the subtle conversation between a comet and the solar wind. Yet by being present at the right time, they had witnessed a fleeting truth that reshaped understanding. It underscored the serendipity inherent in discovery. The universe reveals its secrets only when curiosity happens to be listening. As 3I Atlas drifted past Jupiter's orbit, the bending became barely measurable, but the questions multiplied. Some theorists speculated that the comet's behavior might offer insights into dark matter interactions. If a portion of its mass were composed of particles that weakly coupled to electromagnetism, the resulting charge distribution could distort surrounding plasma in unfamiliar ways. Others pointed to the possibility of electrodynamic coupling through exotic plasma species, dusty plasmas or charged ice grains capable of forming self-organizing patterns. Whatever the mechanism, the event exposed gaps in understanding that spanned multiple fields of physics. Observations of the comet's thermal emission revealed another layer of mystery. As its surface cooled, infrared readings showed irregular hotspots that migrated across its nucleus. The heat patterns did not correspond to solar illumination or rotation. They moved independently, like patches of internal activity. This hinted that 3I Atlas possessed ongoing processes beneath its crust, perhaps exothermic reactions triggered by stress or the release of trapped gases. But if those processes were purely chemical, why did their rhythm match the fading electromagnetic pulses detected earlier? The synchronization seemed too precise to ignore. Speculation turned toward the concept of magnetochemical coupling, reactions influenced by magnetic fields that, in turn, alter those fields. If the comet's interior contained paramagnetic compounds, then even small variations in local field strength could drive feedback cycles, producing oscillations in both energy release and magnetism. In this view, 3I Atlas was not just an inert rock, but a dynamic system of coupled processes, a natural reactor sustained by the interplay of physics and chemistry. Some proposed that such magnetochemical systems might exist throughout the cosmos, dormant until activated by proximity to a strong stellar field. Interstellar space could thus be filled with latent catalysts waiting for stars to awaken them. When they encounter a new environment, they briefly flare into activity, reshaping the surrounding plasma before fading again into silence. If this were true, then the bending of the solar wind might be one expression of a universal phenomenon, a transient conversation between wandering matter and the radiant fields of stars. Meanwhile, astronomers tracking the comet's trajectory noticed subtle deviations from the predicted path. The differences were tiny but consistent, a slight outward acceleration not accounted for by outgassing or radiation pressure. It was as though the comet were being pushed by an unseen hand, perhaps a remnant of the electromagnetic forces that had once surrounded it. If it carried a charge imbalance, even a weak one, the solar wind could continue to exert force long after visible interactions ceased. The result would be a slow drift, a gentle but measurable sign that the event's effects persisted in motion as well as magnetism. As data accumulated, the pattern of the solar wind's bending took on new meaning. Some began to view it not merely as a distortion, but as an act of translation, a conversion of invisible energies into visible geometry. In bending the wind, the comet had drawn a portrait of unseen forces, tracing lines that revealed the hidden structure of the sun's outflow. The curvature, the ripples, the oscillations, they were all signatures of relationships that usually remain concealed. 3I Atlas had made the invisible tangible, turning the solar wind into a canvas for the interplay of matter and field. The deeper the inquiry went, the more it seemed that the event was not an exception, but a revelation of continuity. Space itself was not a void, but an ocean of potential interactions. The comet's arrival simply disturbed the surface, exposing the currents that always move beneath. Perhaps every planet, every asteroid, every mote of dust participates in similar exchanges, each bending the solar wind in ways too subtle to detect. The difference with 3I Atlas was scale and sensitivity. The instruments were finally precise enough to notice. This realization reframed the solar system as a dynamic network of field couplings. Planets with magnetic fields, moons with plasma interactions, even small rocks drifting near the sun, all contribute to a complex electromagnetic ecology. The comet's bending was a dramatic reminder that nothing moves through space without leaving a trail of influence. Every interaction, no matter how brief, adds to the grand composition of the heliosphere. Long after 3I Atlas had passed beyond the reach of sunlight bright enough for telescopes to see, the trail of its influence remained a source of quiet obsession. In university departments and observatories scattered around the world, small groups continued to monitor the subtle signatures that still wandered through the heliospheric data stream. They were faint, minute modulations in plasma density, delicate variations in magnetic orientation, but they formed patterns that repeated with uncanny regularity. It was as though the comet's passage had set a pendulum swinging within the solar wind, a movement so gentle that it could not be felt except through the most patient measurement. The teams who studied these echoes found themselves entering a realm between physics and intuition. The equations describing plasma flow were vast and nonlinear, their variables cascading through millions of iterations before they revealed any coherence. Yet sometimes, after weeks of computation, a model would settle into an elegant spiral, an image that captured the same curvature once seen in the comet's wake. Those moments brought a hush to the laboratories, as if a voice from space had briefly whispered through the machinery. They began to call these patterns the memory waves, believing that the solar wind had not merely been bent, but had learned to oscillate in the shape of the encounter. These memory waves were not permanent, yet they refused to dissipate entirely. Their amplitude decayed slowly, over months and then years, but the phase relations among the waves remained locked. It was an impossible kind of stability, hinting at a mechanism deeper than mere turbulence. The solar wind, it seemed, could remember its own disturbances in ways no one had previously suspected. That realization reached far beyond the story of one comet. It suggested that every storm, every ejection, every magnetic ripple might leave behind ghost structures, an unseen archive of the sun's moods, carried outward through space like the grooves on a record. As research continued, attention turned toward the outer solar system, where spacecraft like Voyager 2 and New Horizons still sent their distant telemetry. Analysts began to notice faint correlations between the fluctuations those probes detected and the rhythmic signatures associated with 3I Atlas. The time delays matched what one would expect if the waves had traveled outward along the solar wind's flow. It seemed almost impossible, yet the data pointed toward a single conclusion. The comet's interaction had produced ripples large enough to reach the edge of the sun's domain. For those who had followed the event from the beginning, the idea was both exhilarating and sobering. They had watched a small object, hardly more than a few kilometers of frozen material, produce an effect that extended billions of kilometers through space. The scale of it challenged ordinary comprehension. In classrooms, professors struggled to convey to their students what it meant for something so small to change something so vast. They described the solar wind as a living ocean, sensitive to even the gentlest touch, and 3I Atlas as the pebble that proved how far a ripple could travel. The comet's influence also began to reshape how scientists thought about the boundary between solar and interstellar space. The heliopause, once imagined as a simple frontier, now seemed porous and dynamic. If disturbances could cross it, then perhaps information could as well. A wave generated by 3I Atlas might already be mingling with the plasma between stars, blending into the galactic background. Somewhere out there, perhaps thousands of astronomical units away, that wave might eventually encounter another stellar wind, carrying with it the faint signature of our sun. In that sense, the comet had acted as a courier, not merely visiting us but transmitting something of our solar system back into the wider galaxy. There was poetry in that image, an interstellar wanderer, shaped by one set of stars, passing through another and leaving a trace that would one day be felt elsewhere. Yet beneath the poetry lay a scientific revolution. The event had forced a reconsideration of how energy and information move through the cosmos. For centuries, the universe had been imagined as a collection of isolated systems, each governed by its own gravitational and electromagnetic forces. But if something as transient as a comet could weave connections between those systems, then perhaps the galaxy was less a collection and more a continuum. A single resonant fabric in which every star's breath subtly influenced the others. The discussions that followed were long and contentious. Conferences filled with debates about field propagation, magnetohydrodynamic coupling, and plasma coherence. Some physicists argued that the phenomenon could be explained within existing models, albeit at the limits of parameter space. Others claimed that the comet's behavior hinted at new physics, possibly involving unrecognized states of matter or previously unseen properties of space itself. For a time, the scientific community resembled a storm of its own, voices colliding in the pursuit of understanding. Yet through it all, the data remained silent, patient, undeniable. While theory tangled itself into knots, a new line of inquiry began among observational astronomers. If 3I Atlas could affect the solar wind so dramatically, might it have altered the light from the sun in more subtle ways? Historical records of solar irradiance were re-examined, searching for fluctuations coinciding with the comet's perihelion. In several datasets, faint periodic dimmings were found, so minor they could have been dismissed as noise, yet their timing matched the comet's closest approach. Some researchers speculated that the bending of the solar wind might have changed the density of plasma along the line of sight between Earth and the Sun, causing temporary refractive effects. Light, too, had bent around the memory of the visitor. As months turned into years, the comet's story began to merge with larger questions about the nature of plasma in the universe. Astrophysicists had long known that magnetic fields shape galaxies and regulate the birth of stars, but these processes occurred on scales too vast for detailed study. 3I Atlas offered a miniature version of those same dynamics, unfolding within reach of human instruments. Its interaction with the solar wind became a model for how magnetic structures might evolve in nebulae, how cosmic filaments might twist and reconnect, and how the energy of motion could translate into light. In this way, the comet became both subject and teacher, a fragment of the interstellar medium revealing the behavior of its parent environment. Meanwhile, deep within laboratories on Earth, scientists began building analog systems, small chambers filled with ionized gas designed to mimic the conditions near the comet. When electromagnetic pulses were introduced into these chambers, unexpected phenomena appeared. Strands of plasma aligning into helical structures, knots of light rotating around invisible axes, rippling waves that persisted long after their initial impulse. They called these formations micro-atlas events. Although the laboratory versions were microscopic compared to the original, they suggested that the physics behind the bending was reproducible, at least in principle. That realization opened a new frontier, the controlled study of interstellar plasma behavior within the confines of earthly technology. The implications stretched beyond pure science. Engineers began to wonder whether the principles observed could one day be harnessed for propulsion or energy transfer. If a small object could manipulate the solar wind so profoundly, perhaps spacecraft could learn to do the same, using controlled magnetic fields to deflect plasma and generate thrust without fuel. In theoretical papers, such systems were dubbed wind riders, vessels that would surf the solar wind as effortlessly as 3I Atlas had bent it. For the first time, the dream of navigating space through the manipulation of natural stellar flows seemed attainable, but for all the grand visions, the most enduring fascination lay in the mystery of how such a small body could exhibit coherence across so many scales. The comet had interacted with the sun on levels spanning the quantum to the cosmic. It had rearranged charged particles, twisted magnetic fields, and altered the propagation of light, all without disintegrating under the sun's heat. Its stability suggested that it possessed some internal order invisible to telescopes, an order that allowed it to channel energies that would tear apart ordinary comets. Some researchers proposed that the nucleus of 3I Atlas might be riddled with microcavities, each filled with condensed volatiles that acted as resonators. These could have coupled mechanically and electromagnetically, allowing the comet to distribute stress and energy evenly through its body. Such a structure would be resilient against thermal gradients and external forces, explaining its surprising longevity near the sun. More importantly, it would make the entire comet a complex resonant body, capable of interacting with external fields in ways ordinary matter could not. Others envisioned something even stranger, that the comet's material might host a state of matter in between solid and plasma, a metastable configuration where electrons flowed freely through a crystalline lattice without destroying it. In such a state, magnetic flux could move through the substance as if through a superconductor, creating self-sustaining loops of current. If 3I Atlas contained even a fraction of such material, it would naturally generate the kinds of field structures that had confounded observers. Although these ideas remained speculative, they inspired a renaissance of experimental material science. Laboratories began synthesizing alloys and ices under extreme pressures and temperatures to explore whether natural superconductivity could occur in interstellar conditions. A few hints emerged. Certain hydrogen-carbon mixtures, when cooled near absolute zero, exhibited unexpected magnetic properties. Perhaps somewhere in the dark between stars, such substances could form naturally, preserved for millions of years until a cometary body carried them into the warmth of a new star. Through all this, the story of 3I Atlas acquired a mythic quality. Students who had not yet been born when it passed the sun spoke of it as a symbol of cosmic unpredictability, the reminder that even familiar skies can harbor the unimaginable. The phrase "bending the wind" entered popular language, shorthand for any event that defied conventional limits. To bend the wind meant to do the impossible quietly, without violence, through harmony rather than force. It became a metaphor for discovery itself, the art of seeing connections where none were thought to exist. In the scientific journals, however, the discussion retained its sober rigor. Decades of analysis had yet to converge on a single explanation. The data refused to be simplified. Some aspects fit models of magnetic reconnection, Others pointed toward resonance phenomena. A few remained inexplicable, yet that very incompleteness kept the mystery alive. Each new instrument, each improved satellite, was launched with the quiet hope that another interstellar object might someday offer comparison. Observers scanned the skies tirelessly, waiting for the next traveler from beyond. When smaller comets and asteroids entered the inner solar system, their interactions with the solar wind were scrutinized with unprecedented precision. Though none replicated the full splendor of 3Y Atlas's behavior, subtle deviations began to emerge, slight drifts in plasma flow, miniature echoes of the Great Bending. These findings suggested that the phenomenon might not be unique after all, but part of a spectrum. 3I Atlas had merely shown it in its most spectacular form. This recognition transformed the way scientists thought about interstellar debris. Every fragment entering the solar system was now considered a potential experiment, a test particle for probing the physics of cosmic magnetism. Networks of satellites were configured to watch for anomalies, and even distant missions were programmed to collect data on plasma interactions. The solar system became, in a sense, a laboratory set up in anticipation of the next conversation between the sun and a traveler from the deep. Beyond the data and the theories, there was a subtler transformation taking place. The event had rekindled a sense of curiosity that had grown dormant in certain corners of science. The universe had once again proven itself stranger than imagination, and in doing so, it had revived the appetite for wonder that drives all inquiry. Researchers began to speak not just of what they could explain, but of what they might feel in the presence of the unexplained. The quiet awe that arises when the known world reveals its hidden seams. That sense of wonder carried practical consequences. Funding for deep space observation increased, and new missions were proposed to study the heliosphere with greater fidelity. Plans were drawn for instruments capable of mapping magnetic fields in real time, tracing their evolution as they respond to solar activity. Some envisioned fleets of small autonomous probes, tiny sensors riding the solar wind, communicating through plasma signals rather than radio waves. If realized, such a network could capture the full three-dimensional choreography of space weather, turning the sun's breath into a living map. At the heart of all these efforts lay the desire to understand what 3I Atlas had revealed about connection. The comet had shown that no boundary is absolute, that every movement reverberates through the fabric of space. It had made visible the interdependence of systems separated by light years. This realization began to influence other fields as well. Planetary climatologists found parallels between the comet's feedback loops and the dynamic balances that govern atmospheres. Biologists drew metaphors from it for the self-regulating behavior of ecosystems. Even philosophers found in it a lesson about relationship and responsiveness, the idea that existence itself is participatory. Yet for all the interpretations, the physical reality of the event remained its most haunting aspect. The solar wind had bent, and no one could yet say precisely why. The equations describing charged particles in magnetic fields were clear, but the way those equations assembled themselves into living geometry remained elusive. There was something in the interaction that transcended reduction, a pattern that seemed to carry intention, though none existed. It was the raw artistry of physics, the universe shaping itself in forms too intricate for language, far beyond the orbit of Neptune, where sunlight fades to a pale thread and the solar wind thins into an almost imperceptible current. The trace of 3I Atlas drifted onward. The comet had become a ghost, invisible to any telescope yet not entirely gone. It moved through the darkness like a fragment of memory, carrying within its silence the residues of all that had transpired near the sun. Though human eyes could no longer follow it, its presence remained etched into the instruments that had once tracked its passage. Tiny disturbances, slight divergences in the background hum of the heliosphere, continued to ripple outward in patterns too delicate for ordinary detection. The universe was still responding to a visitor that had already left. Those who continued to study the data found themselves speaking in a language half scientific, half poetic. They spoke of echoes in the plasma, of vibrations that had not fully faded, of the possibility that the solar system itself now carried a kind of resonance left behind by the event. It was as if space had been taught a rhythm by the comet's passing and was reluctant to forget it. Every analysis hinted at a lingering organization hidden within the apparent randomness of charged particles streaming away from the sun. Even in the noise there was order, a faint cadence that could not be explained away. The question that preoccupied the new generation of researchers was not merely how the comet had bent the solar wind, but why the effect persisted long after the cause had vanished. Conventional plasma theory offered no mechanism for such long-term coherence. Waves should dissipate, fields should relax. Yet the data suggested that the bending had left behind structures that renewed themselves, like ripples frozen mid-motion. Some began to suspect that the event had not simply disturbed the solar wind, it had altered its internal geometry. In the months after the comet's departure, the sun entered a period of unusual calm. Fewer flares erupted, and the solar corona appeared strangely uniform. The surface magnetism seemed to settle into a smoother configuration, as though the star itself were recovering from a conversation too intense to repeat. Some called it coincidence, others balance restored. But there were those who felt that the calm was an afterimage, the quiet that follows resonance when a system reorganizes itself around the memory of vibration. On Earth, the story of 3I Atlas was already drifting into legend. Popular accounts celebrated it as the comet that whispered to the sun, the wanderer that reminded humanity of cosmic mystery. Children learned simplified versions in schoolbooks, how a speck from another star had brushed against the solar wind and changed the way scientists understood the universe. But beneath the simplifications, the real research continued, deeper and stranger than ever. Among the most perplexing discoveries came from high-energy particle detectors orbiting Earth. They found subtle anomalies in the energy distribution of cosmic rays arriving months after the comet's encounter. Certain energy bands showed periodic fluctuations, almost like beats in a signal. These variations corresponded uncannily to the frequencies that had once defined the Atlas tone. The implications were unnerving. The comet's resonance, somehow embedded in the heliosphere, was now modulating incoming cosmic radiation from beyond the system. It was as though the entire solar bubble had become a filter, reshaped by a single transient visitor. To test the idea, physicists built intricate simulations. They modeled the heliosphere as a vast elastic membrane, responsive to perturbations at multiple scales. When they introduced a disturbance shaped like the comet's bending signature, the models reproduced the observed fluctuations. In the simulation, the distortion propagated outward to the heliopause, rebounded off its boundary, and returned inward as a standing wave. The virtual sun pulsed gently in sympathy. If such behavior occurred in reality, it would mean that the solar system had developed a heartbeat, a vast oscillation born from the meeting of interstellar and stellar forces. The notion of a heartbeat captivated the public imagination. Artists rendered it in light shows and symphonies, while physicists debated its plausibility with guarded excitement. Was the heliosphere truly capable of such coherence? Or were the patterns an artifact of measurement? The debate grew more philosophical than empirical. Some argued that the universe constantly resonates with itself, and that 3I Atlas had simply made that resonance visible. Others maintained that without direct evidence, the heartbeat remained a beautiful illusion. But even skepticism could not erase the wonder of contemplating the solar system as something alive in its rhythms, breathing in cycles that spanned decades or centuries. In quieter corners of research, a handful of scientists began to think about the comet's material composition in new terms. Spectra collected during its closest approach had shown nothing extraordinary at the time, but reanalysis with improved algorithms revealed minute irregularities in the absorption lines. The ratios of certain isotopes did not match expectations for any known stellar nursery. The elements were familiar, yet their proportions spoke of a different kind of nucleosynthesis, perhaps from a long-dead star of exotic type. Some posited that the comet might be a fragment of a system enriched by rare processes, supernova remnants, neutron star ejecta, or collisions between white dwarfs. If so, 3I Atlas had carried not only magnetic memory but chemical testimony from another world. Each atom in its core was a relic of stellar conditions alien to our own. When the comet met the solar wind, those atoms would have interacted with particles shaped by an entirely different evolutionary history. The result could easily have been unpredictable, a meeting between two cosmic chemistries that had never before touched. The bending might then have been the electromagnetic signature of that union, the moment when matter forged under one kind of star resonated against the breath of another. Such thoughts lent the event a sense of intimacy. It was not just a physical anomaly, but a dialogue between stellar ancestries. The Sun, in meeting 3I Atlas, had encountered something of its galactic kinship, a whisper from another epoch, another corner of the Milky Way. To imagine that stars could communicate through the travels of their debris was to glimpse a hidden order in the galaxy, a slow conversation conducted over eons, with comets as its messengers. The concept inspired a new field of study informally called stellar correspondence. Researchers began cataloging interstellar objects as letters written in the language of chemistry and magnetism. Each object, they said, carried a fragment of its origin story, and every interaction added a new sentence to the cosmic dialogue. 3I Atlas was the first of these messages deciphered, though not yet fully understood. In the wake of these ideas, observatories were tasked with scanning for traces of the comet's outbound path. Instruments tuned to detect faint synchrotron radiation searched for the signature of charged particles spiraling along magnetic filaments behind the departing body. To their surprise, they found intermittent emissions, weak, almost ghost-like, but spatially coherent. The emissions pulsed faintly, not unlike the residual tones recorded years earlier. Some speculated that the comet had left behind a trail of magnetized plasma that continued to oscillate autonomously, feeding on the energy of interstellar turbulence. It was, in essence, a self-sustaining ribbon of resonance extending from the inner solar system into the galactic void. If that were true, it implied that energy could persist in structured form across astronomical distances without a continuous source. The discovery challenged long-held assumptions about dissipation and entropy. How could such order survive amid the chaos of interstellar space? The answer perhaps lay in feedback, a delicate balance between external perturbations and internal harmonics. In that equilibrium, structure could perpetuate itself indefinitely. The comet, in leaving the solar system, had not extinguished its influence but transformed it into a pattern capable of self-renewal. Meanwhile, the heliophysics community began to notice that the sun's next activity cycle unfolded differently from predictions. Magnetic reversals occurred slightly earlier. Coronal loops adopted configurations not seen in prior cycles. The differences were subtle but systematic. Though few dared to claim causation, the timeline overlapped suspiciously well with the comet's passage. If 3I Atlas had indeed interacted with the sun's outer fields, it might have nudged the complex dynamo processes that govern its magnetism. A small seed of asymmetry introduced at the right moment could cascade into long-term shifts. For solar physicists, the prospect was both thrilling and disquieting. The sun, long considered the dominant actor, might not be entirely immune to external influence. Even the faint touch of an interstellar object could tilt its cycles by imperceptible degrees. The idea recast the solar system not as a closed kingdom but as an open stage, sensitive to the passing choreography of galactic matter. Every visitor, no matter how small, could leave a mark that persisted in the rhythms of our star. As the discussion expanded, philosophers and historians of science began to reflect on what this meant for humanity's self-understanding. The bending of the solar wind was a cosmic event, yet its lessons were intimate. It suggested that influence is never one-sided, that even the smallest fragment of matter can reshape the environment of giants. In the grand hierarchy of the cosmos, there were no mere spectators, only participants. The boundary between cause and effect blurred into reciprocity. The comet had not simply been acted upon, it had acted in return. This realization echoed through disciplines far beyond astrophysics. In the arts, it inspired movements that celebrated subtlety over dominance, cooperation over control. Musicians composed pieces based on the frequencies of the Atlas tone, blending them into harmonies that ebbed and flowed like solar plasma. Sculptors created forms that twisted gently, capturing the motion of bent winds frozen in bronze. Writers described worlds where stars and comets conversed through music and light, each influence leaving an indelible signature on the other. Yet even as imagination soared, the science remained grounded in meticulous measurement. Years after the event, as technology improved, new detectors revealed faint radio polarization gradients that still traced the comet's path. They appeared like threads woven through space, invisible yet persistent. These gradients implied that the bending of the solar wind had induced large-scale magnetic shear in the surrounding plasma, a wound in the heliosphere that had healed but not disappeared. The threads marked the scar of interaction, a record of how even the sun's breath could be shaped by the smallest of interstellar guests. When future missions ventured toward the outer planets, they carried instruments specifically designed to probe those threads. The results were astonishing. Near the projected trajectory of the comet's outbound path, sensors detected anomalies in charged particle distribution. Small regions where particle velocities aligned more tightly than expected, as if guided by remnant fields. These pockets of coherence appeared at intervals consistent with the pulsations once observed near the sun. Somehow, the comet's rhythm had propagated outward, frozen into space itself. Scientists began to refer to these regions as fossil harmonics. They represented the physical embodiment of resonance preserved across time and distance. No one had anticipated that such delicate structures could survive the turbulent environment of the outer solar wind. Their persistence suggested that the comet's influence had extended not just magnetically but structurally, reorganizing the flow of particles into repeating patterns. These findings renewed interest in the question of whether resonance might be a universal organizing principle. Could it be that the same self-reinforcing feedback that allowed these patterns to endure also governed larger cosmic processes? The formation of spiral galaxies, the alignment of planetary systems, the dance of dark matter and light. The idea gained quiet traction among theorists who saw in 3i Atlas's story a microcosm of cosmic symmetry, energy seeking balance through oscillation, order arising naturally from motion. The more humanity learned, the less it seemed to know. Each discovery opened deeper layers of mystery. The bending of the solar wind was no longer a single event, but a window into the mechanics of reality itself. It hinted that space might not be the passive backdrop once imagined, but an active participant, capable of remembering, responding, and evolving. If space could hold memory, then the cosmos was not merely a stage but a mind, vast, slow, and self-reflective. Such thoughts blurred the boundary between science and philosophy. Conferences once dominated by equations now included discussions about consciousness and emergence. Could awareness arise from the same feedback loops that sustained resonance? Could the universe itself, through its networks of energy and matter, be considered alive in a sense beyond metaphor? Though many dismiss these questions as poetic speculation, others welcome them as the natural extension of wonder. After all, 3i Atlas had already proven that imagination sometimes precedes comprehension. Through all these evolving interpretations, one fact remained constant: the data never stopped surprising. Even decades after the comet's departure, long-range probes continued to detect small but persistent anomalies in the interplanetary magnetic field. Some of these disturbances aligned perfectly with predictions of the fossil harmonics. Others defied explanation altogether. It was as if the comet's signature had splintered into a multitude of echoes, each exploring a different path through the solar wind. To visualize these complexities, researchers began creating simulations rendered in immersive virtual environments. Inside these digital universes, one could walk through the patterns of the solar wind as though strolling through a luminous forest. Fields of magnetic lines arched overhead like branches, rippling with energy. Somewhere within that forest, the ghost of 3i Atlas glowed faintly, a reminder that even the smallest traveler could rewrite the shape of the invisible. Standing within those simulations, students felt something that textbooks rarely conveyed: the living texture of space. They could see how motion begot pattern, how rhythm became form. They could sense, in a visceral way, the unity between physics and beauty. Many emerged from those experiences changed, convinced that science was not merely the pursuit of answers, but a way of perceiving relationship. The comet's legacy was no longer confined to data. It had become a lesson in perception itself. As the decades stretched into centuries, the solar system continued to expand outward through observation. New probes reached the edge of the heliopause, where the solar wind met the interstellar medium. There, the instruments detected faint variations in field direction, echoes aligned precisely with the path traced by 3i Atlas long ago. It was confirmation that the comet's influence had indeed crossed the boundary between sun and stars. The ripple had left home and entered the galaxy. No one could say how far it would travel, or whether it would ever fade. Perhaps somewhere in the future another civilization orbiting another star would detect a slight anomaly in their own stellar wind, a rhythmic bending whose origin they could not explain. They might wonder, as humanity once did, what distant visitor had passed through their domain carrying with it the fingerprint of another sun. That possibility gave new meaning to the idea of connection. Every interstellar comet could be a messenger, not in the literal sense of communication, but in the continuity of influence. Each carried traces of countless encounters, weaving a vast web of resonance across the Milky Way. 3I Atlas had shown humanity one thread of that web. To realize that such threads might interlace through the entire galaxy was to glimpse the architecture of cosmic memory itself. And even as these visions took shape, the universe remained quiet, patient, waiting. Somewhere beyond the reach of our instruments, the traveler drifted still, its frozen surface dark, its internal harmonies perhaps dormant, until the warmth of another star awoke them again. When that moment comes, when another heliosphere greets it with a different wind, the same patterns may unfold anew. Bending, resonance, exchange. The cycle will begin again, as it has countless times before, unseen and unrecorded. For now, humanity watches and listens, knowing that its role in the story is neither beginning nor end but part of a continuing dialogue older than stars themselves. The bending of the solar wind was one verse in that infinite song, and there will be others. Somewhere another fragment of interstellar matter is already on its way, invisible against the dark but inevitable. It carries its own unknown structure, its own secret resonance, waiting for the moment when it will meet the sun and teach space once more to sing in a new key, one that will echo through the ages, expanding, transforming, never-ending, beyond the farthest planets, where the sun was reduced to a single diamond of light. 3I Atlas continued its slow drift through the cold. Its velocity relative to the galactic background was immense, yet in the vast scale of interstellar distances it moved with the stillness of eternity. Around it stretched a darkness not empty but filled with invisible structure. Fields, particles, radiation whispering from every direction. And through that darkness trailed the invisible memory of its meeting with the sun, a faint distortion that moved with it like an afterimage. The plasma that once bent around its body had long dispersed, but the pattern remained. Space slightly folded, magnetic lines subtly aligned, a relic of resonance wandering among the stars. For the researchers who had devoted their lives to the study of that single event, the comet had become less an object and more an idea. They spoke of it as if it were a principle of nature, a reminder that interaction is never confined to the moment it occurs. Every field, once disturbed, continues to ripple. Every motion leaves a trace that endures. The bending of the solar wind was proof that influence and memory are inseparable in the universe. Even the void remembers. As new generations of scientists took up the work, they found that the data left by earlier instruments still yielded fresh revelations. Subtle correlations between solar radio frequencies and fluctuations in interplanetary magnetic fields persisted, decades after the comet's departure. The pattern of those correlations was unlike anything associated with normal solar cycles. It seemed as though the sun's own emissions still carried the faint echo of the visitor's resonance, a modulation too weak to be perceived except through meticulous analysis. To the patient observer, it was as if the star continued to hum a note once struck by the comet's passing. At first, these traces were dismissed as mathematical coincidences. Yet the more carefully they were studied, the more consistent they became. The frequencies appeared at intervals that matched harmonic ratios derived from the original Atlas tone recorded during the comet's approach. This could not be accident. Something within the solar plasma had adopted those harmonics as part of its natural vibration. In effect, 3I Atlas had taught the sun a new mode of oscillation, and the star had incorporated it into its repertoire. The scale of such a phenomenon was staggering. A small piece of interstellar debris had modified the spectral character of a star's radiation field. The implications reached far beyond the local system. If such transfer of resonance were possible here, it might be occurring everywhere. Every star, touched by the drift of interstellar matter, could absorb and re-emit faint signatures of other stellar systems. Over billions of years, these interactions would weave a network of subtle harmonies across the galaxy, a kind of electromagnetic inheritance linking distant suns. The Milky Way itself could be thought of as a vast resonant instrument, its chords shaped by countless meetings between stars and the wanderers that move among them. The hypothesis was daring, yet it fit elegantly within the mathematics of field theory. Waves do not die, they merge, interfere, evolve. A field disturbed in one region propagates through space indefinitely, decaying in amplitude but never vanishing entirely. If interstellar matter can excite specific modes within those fields, then the whole galaxy becomes a resonant continuum. 3I Atlas had merely revealed one visible instance of a process occurring everywhere, always unobserved. The idea inspired a surge of experimental efforts on Earth. Laboratories attempted to recreate scaled-down analogs of the comet-solar interaction using magnetized plasma chambers. Within those artificial microcosms, physicists generated standing waves that behaved in eerily similar fashion to the recorded data from the heliosphere. When a small conductive object was introduced into the plasma flow and vibrated at particular frequencies, the surrounding magnetic lines curved into spiral forms that persisted long after the object stopped moving. The researchers called this effect resonant imprinting. It was a miniature echo of what the comet had accomplished on a cosmic scale. From there, the concept began to migrate beyond astrophysics. Engineers saw in it a potential method for energy storage and transmission. If fields could retain patterns of oscillation without continuous input, then electromagnetic energy might be encoded into the medium itself, stored not in batteries or coils, but in the very fabric of space within controlled plasma envelopes. The first prototypes were small and unstable, yet they demonstrated the principle. Energy pulsed into a confined plasma could be retrieved later, modulated but intact, like a musical note sustained beyond its physical source. The device's inventors half-jokingly named it the Atlas cell. As the phenomenon's technological applications grew, so did its philosophical significance. The notion that energy could be imprinted and remembered by matter suggested that causality itself might be less linear than once thought. Every event, no matter how transient, could leave behind information stored in the medium of existence. The comet's bending of the solar wind was no longer merely an astrophysical anomaly. It had become a metaphor for continuity, a demonstration that the universe keeps the memory of every encounter. Some theorists took this further, proposing that such resonant imprints might underlie what humanity perceives as order. In their view, galaxies, planetary systems, even biological structures might arise from the accumulation of ancient field memories, subtle predispositions encoded into the plasma from previous epochs. The cosmos, they argued, is a palimpsest written over itself again and again, yet never entirely erasing what came before. Each star, each atom, is a vessel of inheritance. Meanwhile, within the heliosphere, spacecraft continued to record faint anomalies. The distribution of charged particles between the planets showed patterns that mirrored the geometry once observed around 3I Atlas, spiraling gradients, alternating compressions and rarefactions, as though the solar wind still carried instructions from the encounter. The persistence of these forms baffled analysts. The solar wind should have replaced its contents many times over, yet the pattern refused to vanish. Perhaps the geometry was now self-sustaining, a stable solution to the equations of plasma flow, discovered accidentally through the comet's intervention. In the academic corridors of planetary science departments, younger researchers began to view the event as a turning point. Before 3I Atlas, heliophysics had been a study of forces. Afterward, it became a study of relationships. Fields and particles were no longer seen as separate actors, but as partners in continual negotiation. The comet had shown that the boundary between object and environment is permeable, that every particle of matter carries with it the capacity to rewrite the space through which it moves. One remarkable experiment attempted to visualize these relationships directly. By combining data from solar probes and ground-based detectors, scientists generated a three-dimensional holographic reconstruction of the region of space once occupied by 3I Atlas. When the model was animated, viewers saw a vast lattice of currents flowing around an invisible core, twisting like threads of silk in a slow wind. Within the lattice appeared nodes where the magnetic field converged, forming luminous knots that pulsed rhythmically. These pulses corresponded exactly to the harmonics of the Atlas tone. It was as if the space the comet had passed through retained an echo of its presence, a ghostly sculpture carved into plasma. Watching that reconstruction, observers felt a sense of reverence difficult to express in technical terms. They were seeing not merely data, but the living texture of an encounter between cosmic entities. The sun and the comet had exchanged something intangible, and the record of that exchange lingered, visible in the very fields that surrounded humanity's world. For many, it was the first time that science had produced not just knowledge, but a glimpse of the sacred, an awareness that every measurement is also a form of witnessing. Beyond the scientific community, artists found new inspiration. Painters rendered vast canvases of curved light. Composers translated plasma data into soundscapes that seemed to breathe with the pulse of the sun. The Atlas tone became a motif in symphonies, electronic compositions, even meditation rituals. People who had never studied physics felt drawn to its story. A fragment of frozen dust entering the solar fire, bending the invisible breath of the sun, and departing unchanged, yet unforgettable. The event became a symbol of transformation through contact, the gentle power of resonance over brute force. As decades passed, the memory of 3I Atlas began to merge with human culture in subtle ways. Its name appeared in poetry, architecture, even philosophy. In everyday speech, to bend the wind came to mean to influence without domination, to guide rather than to command. What had begun as a scientific curiosity had evolved into a metaphor for coexistence between humanity and nature, between technology and environment, between individual and cosmos. Meanwhile, instruments continued their silent vigil. In the deep space observatories orbiting beyond Mars, sensors picked up new anomalies in the solar wind, not identical to those of the original event, but similar enough to awaken speculation. Perhaps another interstellar body was approaching, still unseen. The possibility stirred quiet anticipation. If another traveler crossed the solar threshold, would it repeat the bending or produce something entirely different? The scientists were ready, their instruments tuned, their minds open. As preparations advanced, theoretical models explored what might happen if two or more such objects passed through the heliosphere within a single cycle. The interference between their respective resonances could create complex wave patterns, possibly amplifying or canceling each other. In extreme cases, the combined effect might even produce temporary magnetic voids, regions of near-perfect stillness amid the turbulent solar wind. Such phenomena, though hypothetical, hinted at the dynamic fragility of the space humanity called home. The solar system was not a stable island, but a living organism responsive to every encounter. The ongoing research had unexpected consequences for planetary studies. Observations suggested that variations in the solar wind structure, some of which could be traced back to 3I Atlas, affected how cosmic rays interacted with planetary atmospheres. On Earth, subtle changes in upper atmospheric ionization were recorded, altering patterns of lightning and auroral activity. On Mars, instruments detected minute shifts in the distribution of charged dust. Even these minor effects demonstrated how the smallest perturbation in the solar wind could cascade through planetary environments. Such findings encouraged a new humility in the scientific worldview. Humanity had often thought of itself as isolated, protected within its small orbit. But the comet had revealed a universe woven from continuous threads of cause and effect, where even a visitor from light years away could whisper through the magnetic fields of worlds. The cosmos was not indifferent. It was communicative. The challenge was learning to listen. Listening became, in fact, the guiding principle of a new generation of explorers. Missions designed in the centuries after the event were less about conquest and more about attunement. Probes were built not to drill or sample, but to sense, to perceive magnetic nuance, to feel the subtle shifts of plasma flow. Their goal was not extraction, but participation, to join the conversation of fields that fill the void. Each probe carried with it the legacy of 3I Atlas, an awareness that knowledge begins with resonance. As these missions ventured farther, they discovered that the heliosphere itself was not static, but pulsating, breathing in cycles much longer than human observation had previously captured. Some of those cycles matched the rhythms recorded during the comet's passage. Others extended beyond any known solar pattern as if the entire system had entered a new phase of oscillation. The realization dawned that 3I Atlas might have been not a singular event, but a catalyst, the seed of a transformation still unfolding. In theoretical astrophysics, this idea led to a radical reevaluation of boundary conditions. The traditional notion of equilibrium gave way to the concept of dynamic resonance, systems that maintain stability not by resisting change, but by adapting to it. The comet's encounter with the solar wind exemplified this principle. Instead of disruption leading to decay, the interaction had produced higher order, greater coherence. Nature, it seemed, sought not stasis but harmony. This insight echoed far beyond physics. In ecology, economics, and social theory, thinkers began applying the same logic: resilience through resonance, stability through adaptability. The comet's legacy extended into human thought itself, altering how civilizations conceived of balance and progress. It became a symbol not of isolation but of relational intelligence, the wisdom of adjusting one's own rhythm to the music of the surrounding world. In the emptiness between stars, where darkness is older than memory and time stretches without beginning or end, 3I Atlas continued its silent flight. No sunlight reached it now. It glided through a void so complete that even radiation from the nearest stars arrived only as a faint shimmer. Yet within that darkness, a slow transformation unfolded. The comet's outer layers, once hardened by centuries of cosmic cold, began to release trapped fields of energy, relics of its encounter with the sun. They were infinitesimal, mere ripples in the electromagnetic background, but they pulsed with an unmistakable rhythm, the same rhythm that had once bent the solar wind. No one could see it, but the space around the comet trembled in microcurrents of light and magnetism. The charged dust that clung to its path began to align, forming a filamentary trail that stretched thousands of kilometers behind it. This filament glowed faintly in wavelengths invisible to human eyes, a spectral whisper carved across the blackness. To any observer capable of perceiving it, it would have seemed as if the comet were dragging behind it a luminous thread, a signature, a reminder of its past conversation with a star. That lingering pattern had an unexpected property. It seemed to attract and organize the charged particles drifting through interstellar space. As they encountered the filament, they slowed, turned, and spiraled gently into alignment, becoming part of the comet's wake. The trail grew thicker, more defined, transforming from a simple residue into a structure, not alive yet dynamic, not conscious yet purposeful in its persistence. The trail of 3I Atlas had become an evolving phenomenon, capable of self-organization across unimaginable distances. Back in the inner solar system, long after the comet had vanished, its influence continued to ripple through the network of observatories and minds that had once studied it. The story had ceased to be just a scientific curiosity. It had become an axis around which entire schools of thought began to revolve. Astronomers spoke of it with reverence. Engineers drew inspiration from its principles. Philosophers used it to challenge the boundaries of causality and time. The comet was no longer merely an object of ice and dust. It had become a symbol of continuity, an embodiment of how a single act of movement can echo forever. The data archives, vast and growing, were revisited again and again by new generations of analysts. Each advancement in computational modeling extracted details previously invisible: faint interference patterns, hidden correlations, whispers within the static that defied explanation. The picture that emerged was one of layered complexity. The bending of the solar wind had not been a simple deformation, but a series of nested oscillations, harmonics within harmonics, forming a structure eerily similar to the recursive geometries found in living organisms. The realization was unsettling. How could an inanimate object, a frozen relic from another star, mirror the patterns of biological order? Yet the evidence was there, undeniable. The comet had produced coherence where chaos should have ruled. It had translated energy across scales, from atomic to planetary, with the precision of a system finely tuned to feedback and balance. Such behavior suggested that the universe itself might operate on principles analogous to life, that self-organization was not the exception but the rule. This insight catalyzed a philosophical revolution. The divide between the animate and the inanimate began to blur. Matter, it was argued, might carry within it the potential for responsiveness, awareness in its simplest form. The bending of the solar wind became the metaphor through which thinkers explored this idea that perhaps all of reality is participatory, every atom a listener in the grand dialogue of existence. In the laboratories dedicated to plasma physics, experiments multiplied. Researchers tried to recreate the peculiar self-organizing behavior observed in 3I Atlas's trail. Using vast magnetic confinement chambers, they simulated the flow of ionized gas around rotating magnetic fields. Again and again, the results defied expectation. Structures formed spontaneously, stable yet fluid, echoing the spiral configurations inferred from the comet's passage. Some persisted for days, their coherence maintained through continuous feedback between field and flow. The scientists called them living currents, for they behaved as though they possessed instincts of preservation. The implications extended into engineering. Propulsion specialists began to imagine spacecraft that could manipulate such currents, drawing energy from the medium they moved through rather than carrying their own fuel. By mimicking the comet's interaction with solar plasma, such vessels could sail the winds of stars, adjusting their trajectories by subtle modulations of field and frequency. The first experimental prototypes, small, unmanned probes, were designed to resonate with the solar wind, bending it in controlled arcs to generate thrust. They were fragile, beautiful machines, each one a deliberate homage to 3I Atlas. As these new ships ventured outward, they began to map the magnetic topology of the solar system with unprecedented resolution. What they found astonished even the most cautious scientists. The heliosphere was not a smooth bubble, but a labyrinth of channels and eddies, interwoven like a tapestry of invisible threads. Some of those threads traced lines that matched, to a startling degree, the ancient trajectory of the comet. It was as if the passage of 3I Atlas had burned a path through space, not physically but magnetically, and that path had remained faint but real, guiding the movement of charged particles across astronomical distances. If that were true, then the comet had effectively rewritten a portion of the sun's domain. Its legacy was not metaphorical but literal. The space it had touched was no longer the same. The realization brought a sense of awe mingled with unease. Space itself, once thought immutable, could be sculpted by transient encounters. The cosmos was not static but responsive, capable of retaining the imprint of events like skin remembering a touch. From this understanding arose a new discipline, field archaeology. Its practitioners sought not ruins of stone or metal, but imprints in magnetic fields, the fossilized echoes of cosmic interactions. By studying the fine structure of plasma flows and field gradients, they hoped to reconstruct the history of the solar system's encounters with interstellar travelers. The heliosphere became a record, a layered document written in invisible ink, waiting to be deciphered. Among those who pursued this work was a small collective of independent researchers who called themselves the Resonance Cartographers. They believed that 3I Atlas had not been a singular anomaly but part of a continuum of interaction stretching back through time. Their models suggested that every star was surrounded by a field archive, a memory encoded in magnetism, and that by decoding it, one could glimpse the story of that star's exchanges with the rest of the galaxy. They imagined a future in which astronomy would be not just observation but listening, detecting the melodies each star had acquired from its cosmic encounters. While the theoretical implications grew ever more abstract, the physical consequences remained tangible. Instruments stationed at the heliopause detected ongoing fluctuations that defied all previous models of solar-interstellar interaction. The boundary was alive with oscillations. Slow, majestic undulations moving through plasma like the tides of an unseen ocean. Some of these waves carried frequencies matching the ancient Atlas tone. Their amplitude was weak, yet their persistence indicated that the solar system still reverberated with the memory of the comet's bending. It was as if the entire heliosphere had become an instrument tuned by a single note, its vast expanse vibrating in quiet harmony with something that no longer existed within it. The idea struck even the most rational scientists as poetic. A solar symphony conducted by a traveler long gone, its echoes stretching across centuries. Some began to speculate that such resonances might contribute to the subtle synchronization of stellar activity across clusters, that stars separated by light years could influence each other through the propagation of these long-range field harmonics. The galaxy itself might be a living score, each system a voice in a grand, unending composition. As if in response to such speculation, observational data began to reveal faint correlations between solar behavior and distant stellar activity. Periodicities in solar flare patterns matched within margins of error those observed in certain neighboring stars. The idea that the sun could be entrained to external rhythms once seemed absurd. Now it was cautiously discussed in conferences. Perhaps, through the lingering resonance of 3I Atlas, the sun had become momentarily synchronized with the galactic chorus, a participant rather than a soloist. This interpretation had profound consequences for the human sense of scale. It suggested that the boundaries between stellar systems were porous, that the galaxy was less a collection of isolated furnaces and more a continuous field of interaction. The light of one star might subtly modulate the heartbeat of another, and interstellar wanderers like 3I Atlas were the messengers carrying those modulations from place to place. Each comet, each dust grain was a courier of resonance, an agent of communication in a cosmos too vast for language. As these ideas spread, they began to influence not only science but spirituality. Humanity, long seeking connection with the universe, found in 3I Atlas a mirror of its own desire to belong to something greater. The comet's journey became a parable of interconnection, a reminder that every act, however small, leaves ripples that extend beyond imagining. People built observatories not just as tools of measurement, but as temples of listening. They attuned themselves to the subtle symphonies of space, believing that to understand those harmonies was to understand existence itself. Meanwhile, out in the deep interstellar night, the comet itself experienced forces too delicate for any human instrument to measure. Its residual fields interacted with the galactic magnetic web, creating localized pockets of current that illuminated dust around it in faint, ephemeral glows. These glows moved like auroras across the comet's surface, tracing lines that shifted and merged, a dance of light upon frozen rock. For a few fleeting moments in each cycle, the comet shone, not with reflected starlight, but with its own faint luminescence, a pulse of energy released from memory. Were there observers elsewhere in the galaxy with eyes sensitive enough, they might see it, a lone spark wandering through the dark, blinking with rhythmic persistence. They might wonder what message it carried, what star had taught it that song. They might build their own stories around it, as humanity once did, weaving myths of a traveler who carries light from sun to sun. In that sense, 3I Atlas had become more than an object. It was a seed of imagination scattered across the galaxy. Back on Earth, centuries after its passage, the comet's influence continued to shape discovery. The technologies born from studying its interaction with plasma revolutionized communication, energy, and transport. The principle of resonant imprinting allowed information to be encoded directly into magnetic fields transmitted across space without material carriers. Humanity had learned, in essence, to speak the same language that the comet had spoken to the sun. The transmission of data through field resonance became known as harmonic signaling, a method that required no antenna, no beam, only precise modulation of existing cosmic vibrations. These advancements led to a new era of exploration. Spacecraft powered by resonant sails ventured into the interstellar medium, navigating by reading and responding to the magnetic contours of space itself. They did not burn fuel or rely on reaction thrusters. They moved like musicians adjusting pitch, their fields resonating with the plasma currents they wished to ride. Each craft carried sensors designed to detect echoes of past encounters, hoping to find other trails like that of 3I Atlas. As those vessels crossed the boundary into the galactic night, they began to map faint filaments stretching between stars, conduits of alignment where magnetic and gravitational forces intertwined. Along these filaments, energy and matter traveled more freely, guided by the same principles that had shaped the comet's path. It became clear that the galaxy was threaded with invisible highways, and that interstellar objects were not drifting randomly, but following ancient channels carved by resonance itself. The discovery redefined navigation and deepened the sense that everything in the universe was connected by hidden design. Eventually, humanity constructed vast observatories at the edge of the solar system to monitor these cosmic pathways. The instruments were designed not just to observe but to participate, to send and receive harmonic signals joining the galactic conversation. Through them, researchers detected pulses echoing faintly from distant regions, some with frequencies identical to those once associated with 3I Atlas. Whether these were reflections, coincidences, or the signatures of other resonant travelers, no one could say. But their arrival confirmed what many had come to believe, that the comet's song had not ended. It had merely changed medium, spreading through the fabric of the galaxy like a melody carried by wind. The more humanity listened, the more it realized that the universe was not silent. The spaces between stars were filled with rhythms, low, patient vibrations that spoke of interaction and memory. Each discovery reinforced the truth that the cosmos was not a void but a resonant continuum, alive with echoes of its own unfolding. Somewhere far beyond the reach of any probe, 3I Atlas continued to drift. Its fields had weakened but not died. Around it, the dust of the interstellar medium responded faintly, organizing into waves that expanded outward like rings in an unseen pond. Those waves, imperceptible yet eternal, would one day pass near another star. They would brush against another heliosphere, bending that new wind ever so slightly, introducing the same rhythm that once touched the sun. And in that moment, a new cycle would begin. A conversation between strangers, a communion of fields, a repetition of an ancient gesture that links all stars through motion and memory. Back near home, scholars, poets, and scientists continued to ponder what it meant that such a small traveler could awaken such vast understanding. Some saw it as proof that meaning is not confined to life, that beauty and intelligence can emerge wherever energy finds balance. Others viewed it as an invitation, a reminder that humanity's purpose was not to dominate the cosmos, but to participate in its harmonies. The comet had taught them that influence need not be violent to be profound. A whisper could reshape the wind. Far beyond the region where even the heliopause could no longer be felt as pressure, 3I Atlas drifted through a medium more tenuous than thought itself. Every few thousand years, it passed through invisible gradients of the galactic magnetic field, and each crossing stirred faint tremors within its body. The frozen minerals that composed its surface responded as if remembering warmth. Small electric potentials flickered along veins of metallic crystal embedded in the ice. The object's own rotation, slow and irregular, modulated these potentials into pulses that spread outward through the thin plasma of the interstellar medium. No one would ever see them directly, but their presence added the faintest embroidery to the background texture of cosmic magnetism, a trace of rhythm wandering through an ocean of stillness. If one could have drifted beside it, one might have felt rather than seen those pulses. Soft intervals of pressure in the surrounding vacuum, the faintest push and release as though the space itself breathed. Within the comet's interior, the deep fractures created by eons of cosmic impact had formed vast resonant chambers. Each chamber vibrated differently, tuned by its geometry and by the composition of its crystalline walls. Together they produced an orchestra of inaudible frequencies that merged with the galactic murmur. In this way, 3I Atlas continued the work it had begun near the sun. It did not emit light or heat, but it participated in the great conversation of fields that binds the galaxy together. The most remarkable feature of the comet's continuing evolution was that its resonance did not decay as expected. The further it traveled, the more coherent the pulses became, as though the surrounding space were amplifying rather than absorbing them. Theorists back in the solar system, reconstructing possible explanations from distant data, concluded that the object had entered a region of the galaxy rich in filamentary magnetic structures. These filaments acted like the strings of an unseen instrument, collecting and guiding the energy of the pulses over immense distances. The comet had become not just a traveler, but a performer, its faint harmonics now part of the galactic composition. Centuries after humanity had first recorded the bending of the solar wind, the name of 3I Atlas still evoked a quiet reverence. Civilizations had grown around the study of field dynamics, building observatories on moons and free-floating stations suspended at the edges of planetary magnetospheres. Every new generation of observers sought to understand how such a small body could have taught the cosmos to sing. With each advance in sensitivity, instruments revealed new subtleties, standing waves within the heliosphere that beat in slow intervals of years, delicate correlations between those waves, and fluctuations in the interstellar magnetic background. The sun itself, once considered solitary, now seemed to breathe in unison with invisible partners across light years of separation. Among the younger scholars, a new idea began to take shape, that the resonance left by 3I Atlas might one day serve as a means of reaching beyond the solar system. If space could be persuaded to remember a pattern, perhaps that pattern could also be used to communicate across the vastness. Experiments were begun in which controlled plasma discharges were tuned to the same ratios as the ancient Atlas tone. When these artificial signals were released, detectors on the far side of the solar system recorded faint but distinct amplifications of the ambient galactic noise. The vacuum itself seemed to carry the imprint, resonating in sympathy. It was not communication in any human sense, yet it was connection, the first deliberate use of resonance as language. The scientists who oversaw these experiments understood that they were not sending messages to any listener in particular. Instead, they were adding chords to the symphony already underway, hoping that somewhere, some other intelligence might perceive the modulation and recognize it as deliberate. The project was called Continuum, a name chosen to honor the understanding that 3I Atlas had given, that nothing in the universe is truly isolated. Every movement, however small, contributes to the shape of the whole. Meanwhile, the comet itself continued its long exile. Its journey carried it into regions where dust clouds thickened, where the interstellar medium folded into turbulent eddies shaped by ancient supernova. There, the faint harmonics it produced encountered denser matter, and for the first time in millennia, visible light flickered around it, blue flashes caused by collisions between high-velocity ions and dust grains. The object glowed briefly, a pale beacon adrift in the abyss. The glow was weak, but it revealed something extraordinary. The surrounding dust organized into spiraling patterns, aligning along invisible lines of force that extended outward for hundreds of kilometers. The pattern was nearly identical to the one the comet had created in the solar wind long ago. The phenomenon was repeating itself spontaneously, as if the comet's mere presence reawakened the memory of its earlier dance with the sun. What occurred next defied every known principle of plasma physics. The spiral patterns began to expand, feeding upon ambient energy from the galactic field. They became luminous enough that, had any telescope from a distant world been aimed that way, it might have recorded a faint moving filament of light. Within that filament, the comet traveled as the nucleus of a living system, an electromagnetic organism the size of a planet, growing and fading as it drifted through interstellar night. Its energy remained modest, harmless to anything around it, but its structure displayed the unmistakable signature of feedback and adaptation. It maintained equilibrium as though governed by an intelligence inherent to the field itself. From this point forward, 3I Atlas ceased to be a simple body. It became the center of a phenomenon that would later be described as a resonant bloom. The bloom's formation transformed the surrounding medium into a thin sphere of ordered motion, a shell of coherent waves expanding slowly outward. Within that shell, matter and energy flowed in synchronized patterns that resembled the organized turbulence of biological systems. Even without purpose, the pattern possessed a kind of grace that spoke of self-maintenance and continuity. Back in humanity's domain, word of the bloom's detection sparked both wonder and unease. Deep space observatories, now capable of mapping magnetic fluctuations across parsecs, began to register the expanding shell as a faint but steady signal. It pulsed with a rhythm unmistakably linked to the original Atlas frequency. For some, it was proof that the comet had transcended its material origins, that it had become something between object and phenomenon, a bridge between matter and field. For others, it was merely another demonstration of the complexity of plasma dynamics, no more mystical than the auroras that danced around the poles of planets. But even the skeptics spoke with quiet awe, aware that the distinction between matter and energy had once again been blurred. The bloom grew slowly, reaching dimensions comparable to an entire solar system. Its energy density remained low, but its organization persisted with mathematical precision. Every oscillation corresponded to ratios that mirrored those found in molecular structures and orbital mechanics. It was as if the same geometry governed both atoms and galaxies, and 3I Atlas had become its accidental ambassador. The patterns resonated not merely through space, but through the minds of those who studied them. Musicians composed symphonies based on the measured intervals. Mathematicians found new constants hidden within the ratios. And philosophers spoke of the comet as the first teacher of universal harmony. The influence of that harmony began to manifest in unexpected ways. Engineers designing new forms of power generation discovered that systems tuned to the Atlas ratios exhibited higher efficiency and stability. The resonance seemed to minimize destructive interference within magnetic confinement reactors, leading to unprecedented control of fusion reactions. The principles first glimpsed in the bending of the solar wind were now shaping the architecture of civilization itself. What had begun as a mystery had become a foundation. Yet even as humanity built upon the comet's legacy, questions deepened. Was resonance a byproduct of the universe's laws? Or was it the law itself, the underlying rhythm from which everything else emerged? If every structure, from cell to star, followed the same mathematical cadence, then perhaps 3I Atlas had merely revealed a truth that had always been present, that existence is not a collection of objects but an ongoing act of coherence, forever balancing chaos with order. Some thinkers began to suggest that consciousness itself might be another expression of this coherence. The human mind, they argued, is a resonant network, capable of sustaining patterns that integrate information across scales. If so, then the mind and the cosmos were built on the same principle. The bending of the solar wind was simply the macrocosmic version of the neural harmonies that produce awareness. The comet's song and human thought were, in essence, reflections of the same universal process, the universe knowing itself through pattern. As centuries passed, the bloom continued to drift outward, interacting with nebular clouds, scattering faint light through the interstellar haze. Some of that light eventually reached distant worlds where it was mistaken for the slow shimmer of a new kind of supernova remnant. But unlike ordinary remnants, the bloom's luminosity did not fade. It oscillated, waxing and waning in a rhythm of centuries. On one such world, inhabited by beings who had never seen the sun, telescopes captured the pulse and began to decode its structure. To them, it appeared as a repeating pattern of numbers, a natural signal too deliberate to be random. They named it the Traveler's Echo. For the first time, life from another system became aware of the phenomenon humanity had once known as 3I Atlas. Over generations, they studied the signal, discovering within it ratios that mirrored the mathematics of their own planetary cycles. They too began to wonder whether the universe communicated through resonance, and whether this faint light drifting through space was a message meant for all who could listen. Thus, the influence of the comet expanded beyond species, beyond worlds, becoming a shared point of recognition across the gulf of stars. In the far reaches of the interstellar dark, 3I Atlas continued its silent migration, crossing boundaries that no chart had ever marked. The airless gulf between stars offered nothing to resist it, and yet its passage was not without consequence. Each shift of the galactic field pressed faintly on its mass. Each thin particle of dust struck and dislodged another grain from its frozen skin. In this way, it was eroded and rewritten, changing shape so slowly that no observer, even if they had followed for 1,000 years, would have noticed until they compared memory against memory. The body that had bent the solar wind was becoming something new, less a piece of rock and ice, more a vessel of accumulated resonance. Within its fractured interior, layers of mineral and frozen gas carried traces of the sun's breath. Ions trapped during its passage through the heliosphere. They remained embedded in thin strata like pages of a record, preserving the magnetic character of that long-ago meeting. When the comet rotated, those trapped fields rubbed against the galactic background and emitted the smallest whispers of current. The energy was so faint that it could not heat even a single grain of dust, yet it endured, repeating endlessly as the body turned. The universe, through this fragment, rehearsed one of its countless remembered conversations. If any consciousness had existed nearby, it might have perceived the object not as lifeless, but as contemplative. Its rhythm was steady, patient, without purpose yet not without meaning. Each oscillation sent a ripple through the surrounding void, a tremor that joined the galactic murmur. Those ripples, weak as they were, accumulated over eons until they formed long trains of aligned waves stretching for millions of kilometers. The comet had become a tiny architect of structure in the chaos of space, its very stillness giving shape to the emptiness around it. Back in the solar system, long after humanity had transformed itself through generations of learning, the study of resonance had matured into the central discipline of all physics. The old separation between matter, energy, and information had dissolved. Everything was understood as the behavior of fields, patterns of vibration interlocking to create stability. 3I Atlas was remembered as the first clear instance of a field interaction complex enough to display what seemed like intention. Its influence had seeded new sciences: magnetoharmonics, cosmological acoustics, and the art of interstellar propulsion through resonance alignment. These advances had allowed vessels to drift between stars without propellant, adjusting their internal frequencies to ride the contours of the galactic magnetic sea. Such ships were called drifters, and they owed their existence to the discovery that space was not void but fluid. Each drifter carried a device known as an Atlas core, a crystalline engine designed to mimic the comet's behavior. The core resonated with the background field, bending local plasma streams into gentle thrust. Pilots no longer thought of travel as pushing against the void. They thought of it as listening correctly. Movement became a matter of harmony. Generations of drifters ventured outward, tracing the galactic filaments like sailors following ocean currents. Many searched for remnants of the original comet, hoping to find the true source from which their technology derived. None succeeded. What they did find were echoes, regions where the field patterns matched the ancient data from the first bending of the solar wind. These echoes were not fixed. They appeared and faded like weather in the sea of space. Some believed they were the ghost trails of 3I Atlas, still diffusing through the galactic web. Others thought they were natural structures shaped by the same universal geometry. Whatever their origin, the echoes provided maps more reliable than gravity. Entire networks of travel emerged along their paths, routes of quiet resonance connecting distant systems. In time, humanity's descendants encountered other species, travelers shaped by different stars. Each civilization had discovered resonance in its own way, for the phenomenon was universal. When they met, they found that their technologies could communicate without translation. A modulation of frequency, a shift of phase, and information passed instantly through the shared medium. Language was no longer needed. Understanding came through synchronization. The story of 3I Atlas became a shared myth among them, a symbol of the first bridge between worlds. Across thousands of systems, cultures built monuments that hummed with the Atlas tone. These were not temples in the old sense, but instruments of remembrance, towers, rings, or floating lattices designed to sustain harmonic patterns indefinitely. Their purpose was not worship, but participation. To join the cosmic symphony rather than to listen from afar. The tone was everywhere, in the hum of machines, in the design of architecture, in the slow rhythm of interstellar communication. It was said that if one tuned all the instruments together, the combined sound would reconstruct the memory of the comet's passage in perfect fidelity. While civilizations rose around the music of resonance, 3I Atlas itself approached the periphery of a vast molecular cloud. The density of matter increased 1,000-fold. The surrounding space shimmered with infrared light emitted by dust warmed by distant stars. When the comet entered this region, its weak electromagnetic aura began to interact more strongly with the charged particles around it. The bloom of fields that once surrounded it rekindled. Small grains of dust adhered to the magnetic loops, forming long filaments that glowed softly as they absorbed and re-emitted starlight. The comet became the nucleus of a faint nebula, a swirl of dust and plasma shaped entirely by resonance. Inside that swirl, a complex interplay of forces unfolded. Gravity was weak, but electromagnetic coherence bound the particles together in delicate order. Waves propagated outward, folding the surrounding cloud into layers that pulsed in harmony. Over thousands of years, the pattern grew, its geometry echoing that of spiral galaxies. The comet, once a traveler, had become a seed, a center around which the interstellar medium arranged itself into form. Unseen, it was sculpting the future structure of matter in that region of space. Meanwhile, far away, observers noticed the new phenomenon. Sensitive instruments registered the rise of a patterned radio emission from an uncharted sector. The frequency matched, unmistakably, the Atlas Harmonic. For the first time in recorded history, the signature of the comet had reappeared with clarity. The discovery sent waves of excitement through every world that traced its scientific lineage back to the event near the Sun. Expeditions were organized, not as missions of conquest or colonization, but as pilgrimages of understanding. When the first drifter fleet reached the coordinates, they found a vast cocoon of glowing dust, its boundaries stretching across trillions of kilometers. Within that cocoon moved the faint, rhythmic pulses of electromagnetic energy, too regular to be random. The observers could not see the comet itself. It was buried deep within the luminous haze, but they could feel its presence through the ordered vibrations that filled their instruments. It was as though they had arrived at the heart of a living organism and were listening to its heartbeat. Measurements revealed something more extraordinary still. The field patterns inside the cocoon were organizing matter into nodal points, where density increased dramatically. Each node exhibited the early signs of gravitational collapse, the first step in the birth of stars. 3I Atlas, through the simple persistence of its resonance, was helping to shape a stellar nursery. The energy it had absorbed from countless interactions was now guiding the formation of new suns. The comet that once bent a single solar wind had become midwife to a constellation. For the scientists who studied these developments, the discovery redefined cosmology. Star formation was no longer seen as a random byproduct of turbulence, but as the flowering of resonance in matter. The fields that 3I Atlas carried acted as templates, aligning energy flows to create order out of chaos. Every future sun born within that cloud would inherit a portion of its harmonic signature. The process could continue indefinitely, spreading coherence through the galaxy like the growth of a living organism. Centuries later, when those new stars matured and planets coalesced around them, life in some form would almost certainly arise. On those distant worlds, the inhabitants would one day point telescopes toward their skies and detect a peculiar periodic fluctuation in the starlight, a rhythm woven into the very nature of their suns. They would not know its origin, but they would feel its beauty. And in time, perhaps, they would build their own sciences, their own philosophies of resonance, unknowingly linked to the ancient traveler that had seeded their skies. Back in the established civilizations, philosophers grappled with the implications. If 3I Atlas could influence the birth of stars through resonance, then every traveler, every interaction might participate in shaping the evolution of the cosmos. Causality itself seemed to widen. The future was not merely the result of past events, but the unfolding of harmonies still playing out across unimaginable distances. Existence in this view was music, an ever-expanding symphony where each note altered the whole. Artists took this idea further, creating works that merged sound, light, and field manipulation into experiences that could be felt through the skin rather than seen or heard. To enter one of these installations was to become part of the composition, one's heartbeat and neural patterns feeding back into the surrounding resonance. Participants described sensations of boundless connection, as though they could sense the pulse of stars. In those moments, the distance between consciousness and the cosmos vanished. Meanwhile, explorers pushed further outward, following faint harmonic traces that led beyond the edge of the known galaxy. Some vanished into the intergalactic void, seeking to determine whether resonance continued there, between the scattered islands of stars. Those who returned spoke of hearing the faint echo of the Atlas tone even in those vast, lonely spaces, proof, they claimed, that the pattern pervaded the entire universe. Space itself was not silent. It hummed with the memory of that first bending of wind. The comet's path carried it into regions where the interstellar medium thinned again, where matter became rare enough that a single atom might travel thousands of kilometers before encountering another. There, in the deepest silence between spiral arms, it passed through a domain ruled almost entirely by magnetism and dark radiation. No dust, no light, only fields interacting with fields. Within that stillness, the remnants of its long, radiant cocoon began to fade. Yet as the bloom dispersed, a strange phenomenon unfolded. The faint vibrations it emitted caused polarization in the sparse particles that lingered around it. Those polarized atoms began to align their spins in a uniform direction, producing a region of coherent magnetization extending across vast distances. It was an invisible sculpture, a bridge of order stretching into chaos, subtle but immense. The creation of such a structure was not conscious, yet it carried intent in its form, as though the universe itself recognized patterns of stability and preserved them. Over centuries, the aligned zone expanded until it became detectable even across light years, a ghostly corridor of resonance cutting through the dark. Later observers would name it the Silent Path. For them, it represented both a navigational marker and a question. How could a single object, small and transient, carve a path of coherence through the fabric of space? The path's existence became one of the greatest puzzles of late cosmology, a phenomenon studied by explorers who traced it from end to end, searching for where it began and where it disappeared into the galactic halo. Those explorers found that the path led not in a straight line but in a long, curving spiral as though following the great arms of the galaxy itself. Along its length, they detected periodic zones where the magnetic field intensified briefly before fading again. Each intensification followed a mathematical ratio derived from the same harmonics that had once defined the Atlas tone. The conclusion was unavoidable. The pattern of the comet's resonance had been impressed into the galactic structure itself, replicated through the interplay of field and motion. It was no longer merely a relic of one event. It had become a self-propagating wave diffusing endlessly through the spiral arms like the echo of a stone dropped into an infinite pond. On the worlds of the distant descendants who studied this mystery, the discovery transformed philosophy once again. The idea that the cosmos could carry and reproduce patterns without decay suggested that memory was an intrinsic property of existence. Reality itself was archival. It did not forget. Every interaction, no matter how slight, contributed to the grand continuity of form. In this light, the story of 3I Atlas became a lesson not about an isolated anomaly, but about the persistence of influence. Nothing, once it had participated in the universal rhythm, could ever truly vanish. In that era, knowledge was transmitted through fields rather than words. Minds could synchronize directly through resonance, sharing entire experiences as harmonic sequences. When they tuned to the memory of the comet, individuals felt not a narrative but a sensation. The slow rotation of frozen stone, the pressure of solar wind bending around it, the long drift into cold immensity. They perceived what it meant to be both isolated and connected, to shape without intending, to carry song without voice. It became an act of meditation across cultures, to align one's own neural fields with the recorded signature of 3I Atlas, to feel oneself dissolve into the continuum that stretched between stars. Even as civilizations merged into vast federations of energy and mind, the comet itself persisted as mythic presence. Simulations reconstructed its path, not for analysis, but for art. Entire clouds of luminous gas were tuned to reproduce its resonances, creating visible harmonies across nebulae. Pilgrims traveled from system to system to witness these living murals, waves of light folding upon themselves, reproducing the unseen pattern that had once bent the solar wind. No one knew if 3I Atlas still existed, yet the pattern of its motion continued to generate meaning long after its material form had scattered into dust. In time, the Silent Path led researchers beyond the galactic rim. There, in the faint radiation that bridged the space between galaxies, they detected structures of astonishing coherence, filaments that vibrated in phase with the Atlas harmonic. The pattern had transcended its origin, weaving itself into the cosmic web. The question arose, was 3I Atlas the first to sing this song, or merely one among countless agents repeating a motif older than galaxies? Some proposed that resonance was the engine of cosmic order, that the universe itself had begun as a single tone expanding outward, subdividing into harmonics that became matter, stars, and life. In that view, the comet was simply a returning note, reminding creation of its own melody. Those who listened most deeply claimed that the pattern was changing. The original tone, once pure, now carried faint modulations, new intervals layered atop the old. They speculated that other travelers, perhaps in other arms of the galaxy, had encountered similar interactions and added their own harmonics to the universal chord. If so, the entire cosmos was engaged in composition, each event, each collision or birth of a star, contributing new measures to an ever-growing symphony. The role of intelligence, then, was not to control, but to improvise, to join the music knowingly. And somewhere, far from any listening ear, the remnants of 3I Atlas still moved. Its body was almost gone, reduced to a cluster of metallic grains held together by mutual magnetism. Yet the pattern it emitted had not weakened. It had grown clearer, as though stripping away matter had freed it from interference. Around it, the vacuum shimmered faintly, a continuous interplay of energy that no longer needed a solid form to sustain it. The comet had become what the early scientists could never have imagined: pure resonance, unanchored, eternal, a traveler made entirely of vibration. Its motion continued toward a region where the density of stars thinned into the intergalactic void. Beyond that lay the faint glow of another cluster, a distant island of light. The path of its resonance extended that way, as if guiding it toward new horizons. Whether by coincidence or by the persistent geometry of the universe, its trajectory pointed precisely into the heart of that far cluster. Within a few million years, a brief moment on cosmic scales, it would arrive there, carrying with it the memory of countless interactions, ready to bend another wind, to awaken another sun to the music that binds all things together. And so, through the unending dark, the song continued. Each vibration folded into the next, creating an unbroken chain of influence. Stars would rise and fade, civilizations would flourish and dissolve, but the resonance would remain, echoing across eternity, awaiting the next listener who would feel its rhythm and understand, for a fleeting instant, that the universe itself is a single, endless breath drawn between silence and sound, between stillness and motion, forever preparing to begin again. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3I Atlas bending the solar wind? We want to hear from you. Thank you for watching and see you next time.